This is R.D. Sharma solution, class 12th, chapter 11. Differentiation exercise is 11.5. Before we go ahead, this whole exercise is dependent on logarithmic differentiation it is. What does it mean? So whichever function you have seen, for example, fx, gx, now when we combine these two functions, mainly in the power or raised to, then one of the function will not be of the content having x, that is fx to the power jx. One of the function will not be a x function or having not a x function. It may be a constant, it may be a value like that. Alright. But when both of the functions are x dependent, then we can only have a solution using the logarithmic differentiation. So if we have a function, say fx to the power gx, let us call it that this is y. You'll see all these in example. Just understand this, that we have to take log. So taking a log will solve our problem because log has a special property, and that property is that gx will come in front. So it will be gx log fx. Now these two are two different functions. They may have x, they may not have x, but when especially they have the x relation, then we can do the product rule, apply the product rule and solve the question. So if we have y is equal to fx to the power gx, the dy by dx will be computed how? So the final dy by dx, when you take log, the final result, this is the final result I am saying, I am not proving it. So it will be fx to the power gx, that is the original function will be here, that is y we are calling, y equal to, and then gx by fx, the differentiation will be of fx, this is the first part, then we have plus log of, this log will be of which one? Will be of fx, and along with this we will have dy by dx of gx. So this is a result. I don't want you to remember it, because when we do the question you'll see how this final result will come. So the important thing is log. So let me tell you about log, just to recall the things which we already done in the previous classes. So if we have x equals to log y, the base is e. This entirely means that e to the power x is y. If you understand this thing, all question will be, or log will be very easy. So a to the power b, you can write it as a to the power log base ab. A is base and b is log b. That is, b will come in front. So we have b log a, they are all same. So one thing is very clear, e and log cancels out. That is how a to the power b will come. Okay. So log a to the power b will be e to the power b log a. The first question is x to the power 1 by x. So one is fx, one is gx. What is fx here? It is x. What is gx here? It is 1 by x. So both are x dependent. They have x here. So we will do one by one step, and these step will make a formation for the other question. So y is actually x to the power 1 by x. The first step is to take log y. That is, you take log on both the sides. Base is already e, always e in this case. So log x to the power 1 by x. And we know that the log with certain thing with the power comes in front. As I already indicated, if we have log x to the power y comes in front. So it will be y log x. If you have log a raised b, b will come in front. b log a, base will be e. So 1 by x will come in front. It will be 1 by x. And this is going to be log x. And here we have log y. Now both sides, the second important step is to take the differentiation on both the sides. d by dx on both the sides. So d by dx of log y will be 1 by y, log y 1 by y, and then since it is y, dy by dx. This y, what we have taken, will be used, okay? Now d by dx of 1 by x log x. So there are two different functions. We'll apply the product rule. So 1 by x it is, then d by dx of log x will do. Then we will have a plus sign or addition sign. Log x differentiation of d by dx of 1 by x. So 1 by x, log x is 1 by x, differentiation is 1 by x plus log x. Differentiation 1 by x is minus 1 by x square. How does it come? X can be taken in the numerator with a negative sign, and x to the power n formula can be applied, and x to the power n minus 1. So minus 1 to the power x to the power minus 1 minus 2 it will be. So when we take it in the denominator, it will be minus 1 by x square. Final will be 1 by x square minus this minus I have taken, this one minus. Then we have log x divided by x square. X square you can take common, x square, 1 minus log x it will be. So this is the right hand complete. But still we have a 1 by y with dy by dx. So we have to take this 1 by y which is in the denominator in the left hand side. This goes to the numerator of the right hand side. What was initially y? X to the power 1 by x. So this is your y, and the final solution is this multiplied by 1 minus log x by x square. Okay. So this is the way you are going to solve the other questions as well, one by one. These are the steps. I hope you got a fair idea about the steps. The basic is clear now. So this is a very big exercise. There are more than 45 questions. X to the power sine x. X to the power sine x means we have two functions which are totally dependent on x. So we'll take y as x to the power sine x. Now take log on both the sides. It will be log y. This sine x will come in front, so it will be sine x log x. What is the next step? We take the differentiation of both the sides, d by dx and d by dx. So whatever I am saying, you have to write it. So this is how you are going to go about it. I am just, trying to help you with logic, how it should be done, or it is done. But the writing you have to do. Log y is 1 by y divided by dx. d by dx of sin x log x will be, we'll take sin x here. Log x differentiation is 1 by x. Then log x outside, sin x differentiation will be cos x. Now you can leave it here because this is already being solved, or you can also do LCM like sin x and plus x into log x cos x divided by x. So it will combine these two different terms into one term. That is the only thing. Both the things are same. But here we don't have dy by dx. Along with this we have a 1 by y also. So 1 by y will go in the numerator, and y is nothing but log x to the power sin x. Y is nothing but log x to the power sin x. This is log x to the power sin x. No, it is y is x to the power sin x. Oh, just there is a mistake I committed. I am correcting myself. It is x to the power sin x. This is your final answer. Clear? So now this taking log, taking differentiation, bringing y on the right hand side, these are the three steps you have to follow in all of the questions. 1 plus cos x to the power x. So y is equal to 1 plus cos x to the power x. Those who want to go ahead, they can just have a reference here. I have already given the answer. So y equals 1 plus cos x to the power x. Take the log on both the sides. Log y will be equal to, when you take log, this x will come in front. So this is going to be x log 1 plus cos x. Take the differentiation, do the differentiation, differentiate both sides. So we have log y as 1 by y dy by dx. Here we have two things, x and log 1 plus cos x. We'll use the product rule in order to differentiate them. X will take, then the differentiation of log, whatever content with log is there, it will come in the denominator. So 1 plus cos x it will be. Now differentiation of 1 plus cos x will be, 1 will be 0. Cos x is minus sin x. So just write minus sin x here. The minus I am bringing here, sin x I am putting it here. Then plus. Now we already differentiated log. So log will come in front now. So we will not be differentiating it because we are using the product rule. d by dx of x is going to be 1. I am not writing it. It's going to be 1. Final is this one only. This is your final result. See, a minus b, if it is minus b plus a, it is, which one is better? A minus b. So we always try to keep like that. So log 1 plus cos x, I am swapping with this one. So just changing the position. minus x sin x divided by 1 plus cos x. And we have a y in the denominator, we have to bring this y in the numerator. And what was y? The initial one, 1 plus cos x to the power x. So we have 1 plus cos x to the power x. This is your final answer. And this is dy by dx. And this is how you're going to go about it, write about it, and show you the examiner. These are the steps I have applied. Next is x to the power cos inverse x. This is a reference for those who want to do it by themselves. Y is equal to x to the power cos inverse x. Take the log on both the sides, logarithmic. So it will be log y is equal to cos inverse x will come in front. So cos inverse x and log x it will be. Now let us differentiate both the sides, d by dx of both the sides. Log y is 1 by y dy by dx. Now we'll use the cos inverse x first because we are differentiating by product rule. So cos inverse x, log x differentiation is 1 by x, and it is done. Now log x will come in front, we have already done that. Cos inverse x is negative 1 by under root 1 minus x square. That is a standard result. Negative 1 by under root 1 minus x square is the final cos inverse x differentiation. So dy by dx, y will go in the right hand side. Y was already x cos inverse x. So let me just write it as cos x to the power cos inverse x. And whatever we got inside will be kept like that. Cos inverse x divided by x minus log x divided by under root 1 minus x square. This is your dy by dx. This is your solution. Log x to the power x. This we have to differentiate. So let me just go through it quickly. Y is equal to log x to the power x. Let us take the log on both the sides. When we take log on both the sides, this x will come in front. So log y is equal to x log of log x. We have x of log x. So there are two terms here. X separate term and the other one is the other term. Then we have to differentiate. Differentiation of left side is quite default now. 1 by y dy by dx, that is always we are using, and this we are using a product rule differentiating. So x will come in front. Log of log x is what? 1 by log x. Log of something is 1 by that thing, and log x also we have to do, so it will be 1 by x. Then we have log x we have already done, so we'll just keep it like that. And differentiation of dy by dx of x is 1 only. So I'm not writing it, it is 1. Then we can cancel these two. We'll only get 1 by log x, and here we have the other term as log of log x. And y we have to bring on the right hand side to finally write the answer. So dy by dx, y was log x to the power x. Next one is log x to the power cos x. So this is how you have to do it. You have to write everything, whatever I'm saying, you need to put it in the ink. So y is equal to log x to the power cos x it is. So dy by dx is equal to cos x, log, first step is log. So log will take log y is equal to cos x in front, then log of log x. Log of log x we have already done just now. So then the next step will be differentiation of both the sides. So d by dx of log y is 1 by y dy by dx, and the right hand side d by dx we have two terms, so we'll apply the product rule. So we'll take the cos x outside. Differentiation of log x will be, this is first term, this is second term. So we have taken already this outside. Differentiation of log x will be 1 by log x, and then log x differentiation also. So log x differentiation is 1 by x. Okay. Then we put a add sign because we are doing the product rule. Log x will come in front. Cos x differentiation is minus sin x. So I'll change it here only. Minus sin x. So this is the final one. No change here. And this is dy by dx. 1 by y dy by dx it will be. Y will go here. So let me write final. Y is log x to the power cos x. Log x to the power cos x. Then we have this as cos x divided by x log x minus sin x you can bring in front. Why it is? Because it is seen like log x sin x. Sin x is included in the log. No, sin x is different. And then we have log of log x. So this is your final answer. Differentiate sin x to the power log x. So let us take this as y. Y is sin x to the power log x. So first thing we'll do is what? We'll take log on both the sides. So log y is equal to, when we take log, this log x which is in the power, it will come in front. So log x, log of sin x. Alright. Then we will do the d by dx. D by dx of this. Please remember this is y, because we are going to employ it, use it. So we have 1 by y dy by dx is equal to, now in differentiation, first log x we are going to apply the product rule. PR I am writing for product rule. Log x, log sin x is, it will be 1 by sin x, and the sin x will be cos x. Then plus log sin x we will take outside, and the differentiation will be of log x, which will be 1 by x. So dy by dx will be equal to, y will take on the right hand side. So we have this sin x to the power log x, which is y, and cos by sin is cot, so it will be cot x log x. So we have log x, cot x we can write in front, because otherwise it will be seen like log x cot x. So cot x is inside log, that's why. Plus log sin x divided by x. So this is your final answer. This is how you are going to write. Whatever I have been saying, taking log on both sides, differentiating, all this you have to write. Next is differentiate e to the power x log x. So this is a question you can try yourself, but those who have some intent of understanding, y is equal to e to the power x log x. I am taking log on both the sides. So this x log x will come in front. So log y will be x log e of e. So log e of e is nothing but e to the power is 1. E to the power 1 is e. So you can just write it as x log s, because log base e is 1 only, as the property of log goes. Now let us take the d by dx of this both sides. Please remember, when you have log base a, say b equals say c, so a raised power c is b. If you understand this, you will understand all about logarithmic. Alright? So exponential and log goes hand in hand. So this log e to the power 1 is e, that is why it will be 1. Log base e is 1. Now let us differentiate now. Log y is 1 by y dy by dx. This is x we are taking, log x is 1 by x plus log x we are taking here, and then differentiation of x is 1. So this is going to be 1 plus log x. Now y we are taking on the right hand side. So we have 1 plus log x multiplied by e to the power x log x, because y is e to the power x log x. So this e to the power x log x is what? See, e to the power x log x is nothing but log of something, say x to the power y is y log x. Y comes in front. So if you take this, it is nothing but e to the power log x to the power x. Log x to the power x, and it is e raised to the power log. And I already told you e and log, this cancels out if it is in the power. So x to the power x will only come. So this you can write it as x to the power x. This is nothing but x to the power x. Alright? Differentiate sin x to the power log x. So this also you can do by yourself, as we have done already 7-8 questions. So the things will remain same. Y is equal to sin x to the power log x. And when we both sides, let us take log y is equal to, when you take log here, log x will come in front. So it will be log x, and then we have sin x. So log x, log sin x, because we are taking log. Now d by dx on the both the sides, d by dx. So log y will be 1 by y dy by dx. So this y we will be actually changing with sin x raised log x. So we have log x. I am using the product rule, log x. So log sin x will be 1 by sin x, and then sin x will be cos x, plus log sin x we are taking outside, and differentiation of log x. So it will be 1 by x. Okay. Actually, this is the answer, because y we are taking on the right hand side, it will be sin x to the power log x. This cos x by sin x, you just have to replace it by cot x. So log cot x plus log sin x by x multiplied by sin x to the power log x is the answer. 10 to the power log sin x. 10 is constant. Okay. Now we will take log. I told you earlier when we started the exercise, fx to the power gx. When fx is a function of x, gx is a function of x, then we apply the log rule, that is logarithmic differentiation we do. But here we have 10 to the power log sin x, and without differentiation, going through the via of log, it will be difficult for us. So we'll have to take a log. So we take both sides log. So this will be log. This log sin x will come in front, and log 10. So this log, you don't have to apply the product rule on the right hand side, because log 10 is constant. So this d by dx of log sin x log 10. So log y will be 1 by y dy by dx. So this log 10 will come in front, log 10. And log sin x will be 1 by sin x, and sin x will be cos x. Okay. So y will go here. So dy by dx will be equal to y, which is 10 to the power log sin x, and then we have log 10, and cos x by sin x is cot x. This is going to be your dy by dx. Differentiate log x to the power log x. Same thing, we are going to take the, I hope you are well versed with the questions. So if you are able to try it yourself. And those who want to write, I have given you already the answer. But those who want to understand, let us see it. Y we will take it as log x to the power log x. And then this log y will be equal to log we are taking. So this log y, this log x will come in front. It will be log x and then log of log x. Log x, log of log x. And here we have log y. So if we differentiate it, it will be on the left, it will be 1 by y dy by dx, because log y differentiation is 1 by y. Then we have to do v dy by dx. And these two, we can apply the product rule here. We'll apply the product rule. So log x, let us take outside. Log x is 1 by log x, and differentiation of log x will be 1 by x, plus log x. Then differentiation of log x will be 1 by x. This is 1 by x. Okay, so this log gets cancelled. You have 1 by x plus log x by x. Log x by x. X is in the denominator. Y you can take in the right hand side. So this dy by dx will be nothing but y into y is what? Log x to the power log x. This is y. And we can take x in the denominator common. So 1 plus log of log x divided by x. This is your final answer. Okay. Differentiate 10 to the power x. So we'll do the same thing here. Y is equal to 10 to the power x. Now let us take log on both the sides. Log y is equal to log of this thing. So 10 to the power x will come in front because it is in the power, and log 10 will remain. Log y is simply dy by this 1 by y dy by dx. So 1 by y dy by dx is equal to log 10 is constant, so you don't have to worry about it. Log 10 is here. Now what is 10 to the power x? See, 10 to the power x, the differentiation of 10 to the power x is, or a to the power x is a to the power log a. The base is e, base has to be e. So a to the power x log base EA. Okay. So let us do this. 10 to the power. I hope you have a you may recall that. So it is a to the power x, differentiation is a to the power x log a. And when you say that this is log 10 is in front and then 10 to the power x log 10 again. So you have two log 10s here. So that will be log squared 10, or you can say log 10 square 1 by y on the right hand side, which is 10 to the power 10 to the power x. So y is here on the right side. So 10 to the power x here. Then log becomes log square, so log 10 square. And 10 to the power x is nothing but 10 to the power x. Okay. So this kind of questions, once you apply the log, it becomes very easy. Otherwise, what is the way we are going to solve it? It will be somewhat difficult. But using the log, the questions, this solution becomes so easy that you just need 2 or 3 steps to complete it. Now differentiate sine x to the power x. Now sine x to the power x, what do we do? If you even say y equal to sine x to the power x, even if you take a log, it is sine x to the power x, not the power of sine. Means it is not, the power is not of sine so that you can take that thing in front of log. No. So now you have to adopt a different strategy here. Y is equal to sine x, so sine you have to bring on the left hand side. So sine inverse y will be equal to x to the power x. So this fx to the power gx, this form has come now. Now apply the log. Now you have to apply the log. So this x come in front, log x it will be log of sine inverse x, basically sine inverse y, sorry. Now d by dx of this, log of sine inverse y. Here also d by dx. Log of sine inverse y will be 1 by sine inverse y, and differentiation of sine inverse y will be 1 by under root 1 minus y square, and then y will be dy by dx. It is not always that on the left you will always get 1 by y dy by dx. It is not always. It depends on the question also. What are you going to get the content on the left hand side? Okay. So x log x, let us take x in first. So log x will be 1 by x. Then log x, d by dx of x is 1. So you have 1 plus log x on the right hand side. 1 plus log x. So I am just taking this on the right hand side. Sine inverse y under root 1 minus y square. Now this will not be the answer, because y we have invented by ourselves here. Nobody has said that y you take. So you have to replace y by sine x to the power x, because actual content is sine x to the power x. So wherever y you find, you just replace it by sine x to the power x. So sine inverse y is sine x to the power x. This is sine x to the power x. And then you have under root 1 minus. Now sine x to the power x is what? Sine x to the power x. Anything of sine square is 1 minus sine square is cos square. Under root 1 minus sine square x, or sine square is whatever content is there. 1 minus sine square theta is cos square theta. And under root cos square theta will be cos only. Okay. So sine inverse sine x to the power x will remain like that. But still the sine and sine inverse gets cancelled. I'll just show you. First let us solve this cos x. So cos x to the power x. 1 plus log x is there. But still we have sine and sine inverse that you can cancel out. When you can cancel this out, only x to the power x will remain. So x to the power x will remain. X cos x to the power x has come from under root 1 minus sine square. And 1 plus log x, we already have differentiated it on the right hand side. So x to the power x, cos x to the power x, 1 plus log x. This is the final result you have. Okay. So this is a question which is not of 1 by y dy by dx type. It is somewhat different. So depending upon the question, the solution strategy will change. Next is sine inverse x to the power x. So we have y equals sine inverse x to the power x. Now take the log y is equal to x come in front, so x log sine inverse x it will be. Now you differentiate both the side. 1 by y dy by dx, dy by dx I am doing on both the sides. So 1 by y dy by dx is equal to x, let us take outside. Log sine inverse, so 1 by sine inverse it will be, and differentiation of sine inverse x will be 1 by under root 1 minus x square, plus, now log sine inverse x you have to take outside now, dy by dx of x is 1. And you don't have to worry about anything now, this is the answer. Just take the y on right hand side. This is final. Alright? This is your final. So you don't have to do anything. We are already at the solution. Log sine inverse x I am writing first, just in order to match the answer, plus x divided by sine inverse x under root 1 minus x square. And this y I am taking on the right hand side. So y was sine inverse x to the power x. So sine inverse x to the power x. This is your final result. Okay. Differentiate x raise sine inverse x. Now this you have to bring in front. Without that, difficult to solve. So we'll take log on both the sides. So y is equal to x to the power sine inverse x. Let us take log y will be equal to sine inverse x will come in front, and this is log x. So sine inverse log x. So we'll apply the product rule, and this is 1 by y dy by dx, same as what we have been doing up till now, and y will be taken on the right hand side as cross multiplication. So those who have got the idea, they can do them themselves, but those who want to continue, please understand we are doing it using the product rule. Sine inverse x, log x is 1 by x, then log x will take sine inverse x differentiation is 1 by under root 1 minus x square. So what do you get? You get sine inverse x divided by x plus log x divided by under root 1 minus x square. And then we have y multiplied here. So it will be x to the power sine inverse x divided by dx is like this. This is how you are going to write everything. Now 10x to the power 1 by x, we have to differentiate this. So this is also a straightforward question, and this is the way you have to solve it. And we are going to adopt the same strategy, that is y is equal to 10x to the power 1 by x. We'll take log both sides, not dy by dx, we'll take log. Log y is equal to 1 by x of 10x. Okay, I am cancelling this, I am taking log. So log on both sides, log y, and d by dx here. So we have 1 by y and dy by dx is equal to 1 by x will come in front and log 10x. So this is 1 by x log 10x, and we'll apply the product rule here. So we'll take 1 by x outside, and log 10x is 1 by 10x, and what is the differentiation of 10x is sec square x. Then we have, I'm not putting the sign because I can see there is a negative coming. So log 10x I'll take out, 1 by x is minus 1 by x square, that we have seen it already. So minus 1 by x square. So this y you have to take on the right hand side. So dy by dx will be equal to y here, which is 10x to the power 1 by x. So this is y only. So 10x to the power 1 by x. And then we have sec square x and x 10x in the denominator minus log 10x divided by x square. This is your answer. So x to the power 10 inverse x we are taking. Same thing we are going to do here. So this is y equals x to the power 10 inverse x. And both sides we are going to take the log. Log y is equal to 10 inverse x. And then log of x. So these two things. Differentiate in the product rule. So left we will be 1 by y divided by dx. is equal to tan inverse x, log x is 1 by x, plus log x, then tan inverse x is 1 by 1 plus x square. So what do you get? Tan inverse x divided by x plus log x divided by 1 plus x square. Y will go on the right hand side. So let's bring it here. So x, tan inverse x into this thing. All this which I am actually speaking, you have to write, like taking log on both sides, differentiating with respect to x like this. X to the power x and under root x. So there are two different terms. The power of x will be the key here. So we have y equals x to the power x under root x. Under root is simply power half. So under root x is x to the power half, x raised to the power half. So when you take log a into b, it will be log a plus log b. Log a into b is log a plus log b. So when we take log on both the side, these are two different terms. So log y is equal to, this is log a, which is log x to the power x plus log under root x. I am writing it as x to the power half. So x to the power half. Because power will come in front. So it will be x log x plus half will come in front, half of log x, and it is equal to log y. So this will be through product rule. Here we don't, half into log x, we don't need any product rule. So this d by dx I am doing for x log x and then for log x, half log x actually. Left hand side it will be 1 by y dy by dx. So x log x is 1 by x plus log x and dy by dx of x is 1. And then we have half log x. So you have half log x is 1 by x. X gets cancelled. Log x then 1 by 2x. Now you can take first and last term together just to give them a solution. So 1 plus 1 by 2x will be, this is 2x plus 1 divided by 2x. So 2x plus 1 divided by 2x and plus log x. And then we have y here on the left hand side, we'll bring it on to the right hand side. So it will be x to the power x under root x. Now you can also, resolve this because the power of x it is. One power is x, one power is half. So you can just add these two also, x to the power x plus half. So x plus half you can write here and that is your answer. So here we have x to the power sin x minus cos x, x square minus 1 by x square plus 1. So we'll apply a trick here. The trick is e to the power log, it cancels things out, right? So we will take this x to the power sin x minus cos x and put it with e to the power log x. Because we know e to the power log x always cancels out. It will give you 1. Okay. So left, this first part will be e to the power log x. If I'm right, log x to the power sin x minus cos x. Because e to the power log base e then cancel out. So only x to the power sin x minus cos x will remain. So either you write x to the power sin x minus cos x or write e to the power log base e x to the power sin x cos x. They both remain the same. So e to the power, this cancels. What I am trying to highlight here is e to the power log cancels out. So why we are writing, you will just see. It will make the question easier. So e to the power log x to the power sin x minus cos x, and these two will cancel out. But when we have log x to the power something, that something will come in front. So log a to the power b is b log a. Here e to the power sin x minus cos x will come in front. Then we have log and x. Okay. So this you can differentiate now. This can be differentiated. So there is total content y I am taking first, you can call it as u, the other you can call it as v, like that. So I am differentiating the first part, e to the power sin x minus cos x log x, and we are going to differentiate it. E to the power anything will be e to the power that thing only. E to the power sin x minus cos x into log x is your differentiation. Now sin x minus cos x into log x, this differentiation has to be done. So what we can do is sin x minus cos x I am taking outside, I am applying the product rule. Log x is 1 by x plus log x will take outside, sin x will be cos x, and cos x will be minus sin x, so it will be plus sin x. So this is whole differentiation of the first part. This is your first term. Now still this is the solution of the first part, and this has to be added with the second part, which we are going to do just now. So this is the first part already done, already kept here. Let us come to the second part, second term of the differential. So I am just changing the color in order to highlight that we are doing the second part now. So d by dx of x square minus 1 divided by x square plus 1. It is of the form p by q. So for that we have to apply the quotient rule. Quotient rule is what? You have x square plus 1 whole square. Then you have x square plus 1. Differentiation of x square minus 1 will be 2x. 2x, and this is going to be 0. So it will be 2x. Then you have minus. X square minus 1 will come out, and x square plus 1 differentiation will be 2x. 2x, and this goes 0. So 2x it will be. So now you can take 2x common from the numerator. You will get x square plus 1 minus x square minus 1. When you take 2x common, it is going to be x square plus 1 minus x square plus 1. X square get cancelled. 1 plus 1 is 2. 2 into 2x is 4x. So numerator will be 4x divided by x square plus 1 to the power square. So this is negative sign. So the first term negative sign, and 4x by x square plus 1 whole square. So this is also something like what we have done just now, x to the power cos x, x cos x plus x square plus 1 by x square minus 1. So the first term you can call it as u, the second term you can call it as v. So when you take it as y equals u plus v, it will be dy by dx equals du by dx plus dv by dx. So u is x to the power x cos x. So log u, let us take log, x cos x will come in front. Log of x to the power cos x, the power comes in front. So it is going to be x cos x and log x. This is your log u. Now let us take the differentiation of this. So it will be 1 by u du by dx is equal to, now when you have 3 terms, we can apply the product rule. So 2 of them will take outside and third will differentiate. And this will do for all the pairwise combination. Alright. So we can do the product rule, we can apply the product rule in 3 terms also, 4 terms also, n terms also. So log x and cos x we are taking outside. Differentiation of x will be 1. So I am not writing it. Plus. Now let us take x log x outside. X and log x. So what is the differentiation of cos x? It is going to be minus sin x. So I am taking it as minus, and sin x I am writing it like this. Plus. Now x cos x, let us take this outside. X cos x. What is inside log x cos x? Log x is 1 by x. So finally is this whole one. Because the last term x cos x by x gets cancelled. So finally what do you get? You have to bring on the right hand side. U was x to the power x cos x. So you have x to the power x cos x. Inside this we have cos x log x. Please remember, always the log x is written after whatever is there. Otherwise there may be a concern that whether this thing is inside the log or not. That is why we always write log at last. So this is the solution of u, du by dx actually. Now if you say du plus v, du by dx is already done, dv by dx we are going to find out. The next time we are going to add with the first term. The first differentiation already got. Now we are doing the second part, and you know it already how to do this. We have done in the previous question just now. So v is equal to x square plus 1 by x square minus 1. X square minus 1 whole square. I am applying the product rule. The quotient rule. So x square minus 1. d by dx of x square plus 1 is 2x minus x square plus 1. This is x square minus 1. The differentiation is 2x. So 2x you can take outside, x square minus 1 minus x square minus 1. So x square get cancelled. You have negative minus 1 minus 2. 2x into minus 2 is minus 4x. So first is this one. This was the second time I am adding minus 4x divided by x square minus 1 whole square. So dv by dx I found out, and I added it with the du by dx. So when we added it, this is the final solution. Alright. X cos x to the power x plus x sin x to the power 1 by x. These two terms separately we have already done. That is, we have y is equal to, this is u, this is v. So dy by dx we have to find out. du by dx plus dv by dx. And then we will add them. Alright. So u is this, v is this. U is equal to x cos x to the power x. So log u will be equal to x log x cos x. First is this one. Then we'll differentiate it. d by dx of log u is equal to d by dx x log x cos x. So 1 by u du by dx. And see, this is log x cos x, log a into b. So when you have log a into b, you can add them, log a plus log b. Log a plus log b. So x this is. So this is going to be log x plus log cos x. So let us multiply this. X into log x plus x into log cos x. Now we will differentiate it using the product rule. For two terms, x log x separately. So it will be x log x is 1 by x plus log x outside. Then d by dx of x is 1. We are not writing it. So x gets cancelled. You will get 1 plus log x it is. Now x log cos x. X log cos x is 1 by cos x. And cos x is minus sin x. Now log cos x comes outside. D by dx of x is 1. Alright. So this gets cancelled, x gets cancelled, you have 1 plus log x minus x, sin x by cos x is 10x plus log cos x, and this multiplied by u. What was u? You can arrange them accordingly, whichever way you want. So du by dx, u goes on the right hand side, it is x cos x to the power x. Let me write here. X cos x to the power x. This is your first term. Now second term will be added. That is x sin x to the power 1 by x. Differentiation will be added here. So I am changing the color just to show you that this second term differentiation we are doing, which is to be added with the first one. So v is x sin x to the power 1 by x. And when we take the log, first log will take. So log v will be 1 by x will come in front. Log of x sin x. Now the way we have done in the first term, log x cos x was log x plus log cos x. Similarly, 1 by x log x plus log sin x. Log a into b is log a plus log b. Alright. Now, so this is x. Let us differentiate this now. So I'm not going to multiply and then differentiate the way we have done in the first one. I'll take 1 by x as one term and log x plus log sin x as another term. See, log v differentiation is 1 by v dv by dx. On right hand, 1 by x I'm taking outside. and this is the second term. The way you can do whichever way you want. Log x is 1 by x, log sin x will be 1 by sin x, and sin x will be cos x. Then we have plus log x plus log sin x will be outside, and 1 by x differentiation is minus 1 by x square. Differentiation of 1 by x. I am using the product rule. 1 by x is first term, the other one is the other term. So minus 1 by x square, you can write minus 1 by x square. So you just have to match the answer, because we just have to multiply. V means, I'm not talking about WE. I'm talking about V has to be, V term has to be multiplied. So multiply this inside if you want. 1 by x square plus cot x into x minus log x by x square minus log sin x by x square. This whole term. Any cancellation you can always do, but multiply this with V please. X sin x to the power 1 by x. X sin x to the power 1 by x. And this term is dv by dx. Previous term was this one. You just have to add these two terms. We have x plus 1 by x to the power x and plus x to the power 1 plus 1 by x. So the first term, if it is different, we can do it differently. Or separately we can call it as u, the other term we can call it as v, and all of it we can call it as y equals u plus v. So dy by dx will be du by dx plus dv by dx. So separately we'll do these two and finally we'll add them wherever it is required. So whenever we have a power, we generally go for the log. So u is x plus 1 by x to the power x. This is u. We'll take log on both the sides. Log u is equal to x log x plus 1 by x. Now let us differentiate it. When we differentiate it, there are two terms here on the left, on the right and left we have 1 by u du by dx. So x will take outside. I am applying the product rule. So log x plus 1 by x is 1 by x plus 1 by x. Then x plus 1 by x is 1 and 1 by x is minus 1 by x square. This we already done earlier. So 1 minus 1 by x square plus log x plus 1 by x will be here and d by dx of x will be 1. Finally, this is the result. And we can now simplify them. So we take the denominator first, which is x plus 1 by x. So I am taking denominator. X plus 1 by x is x square plus 1 by x. And this goes up because this is in the denominator. So x square plus 1 by x goes up. It is going to be x square in the numerator and x square plus 1 in the denominator. And 1 minus 1 by x square will be what? X square minus 1 by x square. So x square minus 1 by x square. So what is the benefit? X square get cancelled. So the final will be u will be posted on the right. So du by dx will be equal to x plus 1 by x to the power x. This remain like that, the u. And what did we get inside? We got x square minus 1 divided by x square plus 1. This one and plus log x plus 1 by x. Now this is du by dx. The second part is to find out dv by dx. Alright? This term is final. You just have to keep it like that. There is no change. But when it comes to dv by dx, that is the differentiation of the second term. Let us do that and just add this to the first term. The result of the first term. So we have lack of space, so I am just clearing it. Now du by dx we have already found out. Now we are going to dv by dx. V is equal to x plus power 1 plus 1 by x. So what it will be, this log v will be equal to 1 plus 1 by x will come in front and then log of x. Now let us differentiate this. So 1 plus 1 by x and this is 1 plus 1 by x. Log x is 1 by x, then log x, 1 plus 1 by x is 1 will be 0 and this will be negative 1 by x square. So this is going to be x plus 1 by x and you always have a x also. Now let us multiply inside, that is the better option. 1 by x into 1 and 1 by x into x square, that is 1 by x square and then minus log x by x square. So if you take the denominator, you can take the LCM. What do you get? You will get here x, then plus 1 and minus log x. So x plus 1 minus log x divided by x square, that is the final result. And one more thing we have to do, log v. So log v is 1 by v dv by dx. So dv by dx is computed by multiplying this with v. So final will be x plus 1, that is x to the power 1 plus 1 by x, that is v. And this is x plus 1 minus log x divided by x square. And this is dv by dx, and dv by dx already found out. We just have to add them. That is the final answer. Okay, these two has to be added. Differentiate e raise sin x and tan x raise x. And there are two things. One way you can go about is by taking log and doing them separately and then adding it collectively in the fag end. But there's another way also, because we know e to the power log is 1. So e to the power log can always be taken, and this e sin x or tan x to the power x, whichever is better to solve with using that, is a better idea. So we have e to the power log and base is e. So this tan x to the power x can always be written because e to the power log base e is 1. I've already discussed it while we started this discussion. When we were discussing about theory, etc. So e to the power sin x, then cos x. I'm doing the e to the power sin x, cos x. So e to the power sin x and sin x is cos x. Now e to the power log tan x to the power x will come in front. So we have to differentiate e to the power x log tan x. So we have to differentiate this. So e to the power x log tan x and x log tan x, because e to the power anything will be e to the power that thing only. And x tan x is x tan x 1 by tan x, and tan x is x square x. Then we have log tan x and d by dx of x is 1. So x log tan x differentiation by product rule is this result. Now the result is e to the power sin x cos x. This is the result for e to the power sin x. And for tan x to the power x, the result will be what? This will remain like that. This will come like that. But see, tan x to the power x was written by us as e to the power log tan x to the power x. That we did. So that can easily be transferred or transformed into tan x to the power x, because that was the actual thing. We started with that thing only. So we have 1 by cos square x into sec square x by tan x. I am telling you 1 by cos square x by sin by cos. So this goes up and this cancel, and finally you have sec x cos x. So x is already there. You get sec x cosec x, and then log tan x plus log tan x. And as I told you, e to the power x log tan x, the whole differentiation is this, but still we have this e to the power x log tan x always there. But since we have ourselves converted tan x to the power x as e to the power x tan x, so you can always write it as tan x to the power x, because it is essentially like that only, because we did that, right? So that is how you can do it, and you can do it separately also, as I told you. You can take the 1 by 1, okay, that is u and v and du by dx and dv by dx, like that. Okay, so this is the tan x to the power x, and then we can just add them. So finally this is the result. Okay, and this content is tan x to the power x, which I have started earlier. Next is cos x to the power x, sin x to the power 1 by x. Again, you can take them u and v, du by dx, dv by dx, add them, that is the final result. But in order to do this, we always have that one thing, that is e to the power log can be cancelled. E to the power log e. So that is the one thing which always cancels itself, e to the power log. So when we take e to the power log, cos x to the power x can be written. Now x come in front, so we have e to the power x log base e cos x. Alright, so this cos x to the power x is, you can always write it as e to the power x log cos x, the base is e. Now we have sin x to the power 1 by x. U and v you can take, or you can use that the power of e to the power log. That is the utility of e to the power log. So e to the power log sin x into 1 to the power of 1 by x also we can write. So what I'm trying to suggest here is e to the power log, always you can write. Now this is 1 only. So after that you can write sin x to the power 1 by x. So e to the power 1 by x comes in front, log sin x it will be. So we have two terms, e to the power x log cos x and e to the power 1 by x log sin x. So what is the utility? See, u and v separately, du by dx, dv by dx, all this, that is a longer way to achieve the answer. Here you will see how easy it will be. Because d by dx of this term, e to the power of anything will be e to the power of that thing only. And this e to the power log cos x is nothing but cos x to the power x. Alright? Then the differentiation of x log cos x. X remains like that, and then log of cos x is 1 by cos x and cos x is minus sin x. Plus, now log cos x will take outside, differentiation of x will be 1. Alright? So this term we can directly write, because we actually started with cos x to the power x. So this is going to be cos x to the power x. Just replace it by cos x to the power x. This is going to be sin by cos is tan, and it is negative. So it will be negative tan x. So I am writing it out afterwards. Minus tan x minus x tan x it is. What is log cos x? Log cos x is log cos x only. So cos x to the power x, log cos x minus x tan x. This from here to here, we have already done cos x to the power x. Now sin x to the power 1 by x, that is e to the power 1 by x log sin x. We'll do it now. So I'm just changing the color just to let you know that we are doing the second term, differentiation. Okay. So e to the power 1 by x log sin x, the differentiation of this will be this only. Now 1 by x log sin x. So 1 by x I'm taking outside. Log sin x is 1 by sin x will be cos x. And then we have, I'm not writing plus because I know 1 by x differentiation is negative 1 by x square. So log sin x will be written like that, and 1 by x differentiation will be negative 1 by x square. So I'm writing negative here. So log sin x, and this is 1 by x square. You can always write like that, x square. So this is the final one. Just one change is there. Cos x by sin x, you can write it as cot x. So finally it will be, this has come from where? Sin x to the power 1 by x. So you have sin x to the power 1 by x, you can write it here. And inside that, we have a 1 by x, cos x by sin x. You can always write it as cot x. So cot x by x it is. Minus log sin x. And then we have divided by x square. This is the second term. So you have to add this one and this one. When you add them, that will be the final result. Alright? Now x to the power x square minus 3 plus x minus 3 to the power x square. So first term you can take it as u, second term you can take it as v. This is u, this is v. And then we write y as u plus v. Du by dx will do, dv by dx will do, whatever the result, we are going to add them up. So let us start with the first term. U is x to the power x square minus 3, and log u is equal to x square minus 3 log x. 1 by u du by dx is equal to, now differentiation using the product rule, x square minus 3 log x is 1 by x, then plus log, minus I am writing, just, no, plus, let it be plus. Then log x will take outside, and then x square minus 3 will be 2x. Differentiation will be only 2x. And then final result will be, you have to take on the right hand side in the numerator. So this u will be x to the power x square minus 3. So x to the power x square minus 3 will come as it is. X square minus 3 by x you can write, plus log x in 2x. So 2x you can write first and then log x. So 2x log x. So this is your first result. So du by dx is this one. Then I am going to tell you, or I am telling you, dv by dx. And that dv by dx has to be added to this term. Alright? You have to add to this term. So let us take this. We have v is equal to x minus 3 to the power x square. So dv by dx, first we will have to take a log v. So x square will come in front, x square log x minus 3 it will be. Here we will have 1 by v dv by dx, and d by dx of this right hand term. X square outside, log 1 x minus 3 will be 1 by x minus 3, and differentiation of x minus 3 is going to be 1 because minus 3 will be 0. So it will be 1 only. I'm not writing it. Now log x minus 3, differentiation of x square is 2x. So you have x square divided by x minus 3. V also you have to take on the right hand side. So x minus 3 to the power x square. This is x square by x minus 3 and 2x will come in front and then log x minus 3. So this term has to be added. They see these two are the results. So these two results have to be added. And this term plus this term. The blue one with the green one, and that has to be added, and that is going to be your final result. Y is equal to e to the power x plus 10 to the power x and x to the power x, and we have to find out the dy by dx. Now you see e to the power x differentiation is direct e to the power x. You don't have to do anything. 10 to the power x, that is a to the power x, is a to the power x log a. So 10 to the power x log 10. X to the power x is the only thing, and we know e to the power log is always 1. So you can always have e to the power log any term, x to the power x in this case. So when you can always take this as w, and w is x to the power x, log w will be equal to x log x, 1 by w, dw by dx is equal to x, let us differentiate it. So x will x, log x is 1 by x plus log x, and d by dx of x is 1. So 1 plus log x it will be. Okay, and then w is already there, so you have to multiply it with w, and w is x to the power x. So the final result will be x to the power x 1 plus log x. So this is one way of doing it. It's a faster way to do it, and the other way is by using e to the power x log x to the power x. That will become e to the power x log x. Now you can apply the differentiation here. E to the power thing will be e to the power thing that. Now what is this one? I told you log e is 1. If the base is e, log e is 1 because e to the power 1 is e only, e to the power 1 is e only. So this log base e is 1. So in place of 1, you can always write log e. That is the only tricky part here. In place of 1, you can write it as log e because log e base e is 1. And plus log base e x. Now log a plus log b is what? Log a into b. So you can write it as log e into x. And x to the power x is already there. So this whole term, you can write it as like this. So x to the power x log ex, that is how it has come. The rest all e to the power x plus 10 to the power x log 10 will remain like that. And second way of doing this x to the power x is e to the power log x to the power x. It will become e to the power x log x. When you differentiate it, the result will come same. The tricky part is only one, which is log e, which we have written, and then we applied the log property. So we have to find out the differentiation dy by dx of this y term, and these are different terms, 4 terms in all. So we'll do them separately. That is x to the power n is simply nx to the power n minus 1, which is a standard result. The first one. Then we have n to the power x. It is type of a to the power x. So a to the power x differentiation is a to the power x log a. Base is e. So n to the power x is, just replace a by n. So n to the power x log n it is. Now n to the power n, see this is n is constant and power is also constant. So n to the power n will be what? d by dx of constant will be 0. Alright. So just to make it as 0. For example 2 to the power 2. If it is 2 to the power 2, it is constant. So it is 0. So d by dx of n to the power n is 0. So first one is this one. Then you have to add this. Then you have to add this. These are the 3 terms. Now we have the x to the power x. That can be done using the log. Okay. So I already told you e to the power log. It cancels out. So you can always write anything in front of that. But the benefit is x will come in front. So we have e to the power x log x. X will come in front. So now you can differentiate this. Differentiation of e to the power anything will be e to the power that thing only. So d by dx of e to the power x log x will be e to the power x log x. And then we'll differentiate x log x by the product rule. So we have x, log x is 1 by x plus log x. Differentiation of x is 1. So what do you get? 1 plus log x. So e to the power x log x into 1 plus log x. but e to the power x log x has come from where? X to the power x. So if you are more experimental, then one more step you can do. One is what? Log e. Log base e is 1. So you can write it as log e, and here you can write it as log x. So log a into log a plus log b is log a into b. So it will be log ab. You can write this as log e into x or x into e. And x to the power x was already there. So first this term, then this second term, 0 is already done. And third term is this one, x to the power x log ex. Okay, this is a kind of algebraic example where we can easily solve this question using the log. You'll see how easy it will become when we will take the log. So you have log a by b form first, then we'll take log a into b as log a plus log b. Alright. If you don't do by log, you will face a lot of, it will not be difficult, it will be lengthy. So let us take log y. Log I am taking. Please remember, log a by b is nothing but log a minus log b. Log a minus log b. Okay. So log a minus log b will do, a is the numerator, b is the denominator. So log, this is x square minus 1 to the whole cube. Then this is 2x minus 1. This is the first part, log a part. Minus log b part. What is b part? This is x minus 3 into 4x minus 3. And since it is root, under root is to the power half. You know already that. This root x is nothing but, root x will always be x to the power half. Root is to the power half. Now log a into b. So log a plus log b will do. So log a into b is log a plus log b. Same thing here. So we'll do log x square minus 1 to the power cube plus log 2x minus 1. This is the first part. Then this half will come in front. Half. And again log a plus log b. A is x minus 3 here. So log x minus 3 plus log 4x minus 1. So this is also the second term. Now let us deal them separately. So since it is of the power x square minus 1 to the power 3, log a to the power b can be written as b log a. So we have 3 log x square minus 1 plus log 2x minus 1 and minus half log x minus 3. I am multiplying negative half inside. So negative half log 4x minus 1. Okay, this is just log. We have not differentiated. Now we'll differentiate. So 1 by y dy by dx will be equal to, so 1 by 1 will do. This is, and this y will go on the right hand side. So I'm not going to write this later, but this y whole you have to write when the answer will be formed. This is the final term. Okay, so 3. Now this is d by dx. We are doing the differentiation now. So d by dx of this. 3 log x square minus 1 is 1 by x square minus 1. And differentiation of x square minus 1 is 2x. Then log 2x minus 1 will be 1 by 2x minus 1. Differentiation of 2x minus 1 will be 2. Minus half. Log x minus 1 will be 1 by x minus 1. Differentiation of x minus 3 it is. X minus 3 is what? 1. Minus half. Log 4x minus 1 divided by 4x minus 1. Differentiation of 4x minus 1 will be 4. So what do you get? You get 6x divided by x square minus 1 first. Plus 2 divided by 2x minus 1. And then minus 1 by twice of x minus 3 minus twice of 2 divided by 4x minus 1. This is your whole result. This is the result. And what is the other thing? This is 1 by y. So y will go on the right hand side. What is y? This whole term you have to write, okay? This whole term has to be taken on the right hand side. The final answer will be like this. Now dy by dx of this term, this is almost similar to what we have done just now. So we'll do what? we'll take log and it will make it very easy. So I'm taking y as the left hand side and then log y. So log y will be equal to log, this is a by b, log a minus log b will do. So log e to the power ax sec x log x minus log a by b is log a minus b. So it will be log, see this is 1 minus 2x root, that is 1 minus 2x to the power half. Half we can bring in front, it will be 1 minus 2x. Now what we will get? So it will be, they are separate terms. Log a, b, c are inside. So log a plus log b plus log c you can do. So log e to the power ax plus log sec x plus log x minus half log 1 minus 2x. Minus half 1 minus 2x. So this is base e, so you can just cancel these two. It will only be ax. Don't worry about differentiation now. See, differentiation, let us do it together. So we have 1 by y dy by dx. So here we have a differentiation of ax will be a. So first we have done what? Log e cancels ax and differentiation of ax is a. Now log sec x is 1 by sec x will be sec x tan x. And then we have plus log x, so we have 1 by log x and 1 by x, log x is 1 by x. Minus half, this is 1 divided by 1 minus 2x, 1 minus 2x, differentiation will be 0 minus 2, so minus 2 it will be. So I am making it plus 2 I am cancelling here only. So what will you get? See, remember this y whole term will go on the right hand side in the final answer. So a sec cancel, you have 10x, 1 by x log x and plus 1 by 1 minus 2x. And as I indicated you earlier, this has to be taken on the right. 1 by y dy by dx, so y goes here. So this whole term you have to write. Alright? This whole term, this is the result we got. Now dy by dx of this term, so this is all clear actually, you just have to take log. There are 3 terms, just add them with log. So we have y, I am taking log y now, log y equals to log e to the power 3x plus log sine 4x plus log 2 to the power x. So a, b, c, 3 terms are there. So log a plus log b plus log c, log e to the power 3x plus log sine 4x plus log 2 to the power x. So log, see this e, of course e gets cancelled. So it is only 3x now. 3x plus log sine 4x will be like that, log 2 to the power x, x will come in front, so x log 2 it will be. Now we have dy by dx, so 1 by y dy by dx, I am differentiating the right hand side. So 3 into x, 3 it will be log sine 4x, so 1 by sine 4x will be cos 4x. This will be cos 4x and 4x will be 4. And then we have this x log 2 is constant. So don't worry about log 2, it will be only differentiation of x which is going to be 1. So 3 cos by sine is cot 4x, 4 of cot 4x plus log 2. Now this is the answer, but you have to take y on the right hand side. This y will be the actual thing, from where we started. Okay. So this is your whole term. This is y. Alright. So if you take log, you see how easy it becomes to solve the question if you just take the log. The complication will be less. Now the second question or the next question, we will take the log. All these terms 1, 2, 3, 4. If you take log, it will be all added in terms of log. So it's quite straightforward. You can just go ahead. But those who want to understand, let me tell them how it is to be done. So log y will be equal to log. So let us call it as p. So if I take log p, It is nothing but the A, B, C, D 4 terms. So you have log P. So log sin x, log sin 2x, like log sin 3x, and log sin 4x. So log sin x plus log sin 2x plus log sin 3x plus log sin 4x. So let us differentiate 1 by y dy by dx. So y is going to be going on the right hand side. So that will be the final one. I'm already showing you the final one. Okay. Now log sin x, differentiation is 1 by sin x will be cos x, plus 1 by sin 2x will be cos 2x, and then 2x will be, differentiation of 2x will be 2, plus, now log sin 3x, so 1 by sin 3x will be cos 3x, and then 3x will be 3, plus log, so 1 by sin 4x, and sin 4x will be cos 4x, and 4x will be 4. So this is going to be cot x plus twice of cot 2x plus thrice of cot 3x plus 4 times cot 4x, and all has to be multiplied by the actual term, which is your y. Alright, because dy by dx is going to be this. So this is y. Just multiply this. All other things remains the same. Now, if log wouldn't be there, it will be very difficult to solve this question. Log has made it so easy. Next is y equals x to the power sin x plus sin x to the power x. You have already done this one part, first and second part, but now we have to do it separately and then add them. Or you can do it together. You can call it one as u, other as v. So y is u plus v, so dy by dx will be du by dx and dy by dx in addition. Let us start with u. U is x to the power sin x. So log u will be sin x log x. Sin x will come in front. So sin x log x it will be. And then we will differentiate both the sides. The differentiation will be 1 by u du by dx is equal to, we'll do using the product rule. So sin x log x will be 1 by x plus log x sin x will be cos x. So dy by dx, or du by dx, sorry, it will be, this u will come in front, so x to the power sin x by x will remain like that, sin x by x plus log cos x, or you can also write it as cos x log x. Always please remember, log is always written as the last term. So you have log x cos x, better to write cos x log x. This is du by dx. So now you have to add it with the other term which I am going to tell you, okay? This is the first term, we already got the first term. Now, the v we are taking, v is equal to sin x to the power x. So log v will be equal to x log sin x. Now we will differentiate them. So 1 by v dv by dx will be equal to, now we will apply the product rule on the right hand side. This is going to be x, log sin x will be 1 by sin x, and sin x will be cos x. Then log sin x, differentiation of x will be 1 only. So x cot x plus log sin x, and we have to multiply v, this v which is sin x to the power x. So this term we have to add these two, and that will be the final answer. If you see the result, it's just nothing, the first parts added with the second part. Alright, this is your answer. Dy by dx, y is equal to sin x to the power cos x plus cos x to the power sin x. Now there are two ways to do. The way we just did, u and v you can find out, or you can symbolize them. You can do du by dx, add them. Now the short form is, or short way to do it, e to the power log can always be written. So anything can be written in front of that. e to the power log sin x to the power cos x. Whenever you write e to the power this thing, log of, say, this term, log sin x to the power cos x will come in front. Similarly, here also the same thing. E to the power log you can write like that. Then this cos x to the power sin x will come in front. So it will be e to the power sin x and log cos x. Alright. Now let us differentiate. E to the power anything will be e to the power that thing only. Differentiation will be like that. Why is this? So dy by dx we have to do. So let us differentiate it. So e to the power cos log sin x and then differentiation of cos x log sin x, and we'll apply the product rule here. So cos x let us take, log sin x will be 1 by sin x and sin x will be cos x. This is the first term. The second term will take log sin x here. So let us add this. Log, I'm not putting the sign, you'll just see log cos x, and this cos x is minus sin x. That is why I changed the sign. Now this e to the power cos log sin x was what? It was initially sin x to the power cos x only. So you can replace it by sin x to the power cos x. And cos by sin you can write it as cot x. This is cos x minus sin x, take in front, sin x log cos x. So this term is the first one. Second one, the second part. So this question we have already done, We are just doing them separately and adding them. So e to the power sin x log cos x, sin x, log cos x is 1 by cos x, cos x will be minus sin x. So let me write it as minus here and sin x here. Plus log cos x, sin x will be cos x. Now since negative is there, we'll just swap the term so that we get negative in between. So from where this e to the power sin log cos x has come? It has come from cos x to the power sin x. So cos x to the power sin x, this cos x log cos x I am writing here, then minus sin by cos is tan x, so tan x, and this is sin x. So this is your second term. Just add these two terms and that will be the final answer. 1 and 2, add them. Okay. Now if we have y equals 10x to the power cot x to the power 10x. So individually we know how to do this, we have already done already. So we will do it separately and then we'll add it. So the first way is to make one as u, second as v, du by dx, dv by dx, then you can add them and equate it to dy by dx. Or there is a shortcut method which is e to the power log. You can write anything in front of e to the power log, because e to the power log base e cancels out. So e to the power log 10x to the power cot x. So you have this cot x come in front. So final will be e to the power cot x log 10x. This is the first thing. Now this is the first thing I am doing, first part. Second you can do it later. So we have this e to the power cot x log 10x. So d by dx of this is going to be the same thing. So e to the power anything will be e to the power that thing only. E to the power cot x log 10x. Now cot x will take outside. Log 10x is 1 by 10x and 10x is sec square x. This is sec square x. Then we have log 10x will take outside and cot x is minus cosec square x. So let us make it as negative minus cosec square x. Alright. So now this is, we can simplify it more. This e to the power cot x log 10x is essentially 10x to the power cot x only. So you can just write it as 10x to the power cot x. Then we have this cot x, x square x, tan x. Let us see what do we get from here. So cos by sine cot is 1 by cos square is x square, and sine by cos, so it goes up, and cos by sine it will be. So this cos square will cancel out, 1 by sine square will go up and it will be cosec square. So here you get cosec square, and since cosec square is in the both the term, first term and second term, So we'll take cosec square common from here. So I'm taking cosec square common. We are left with 1 here minus log 10x. So what do we get? The first answer, the first part is this only. And the second part which we are going to do has to be added to this first part. Alright. So I'll do it with a different color so that you understand we have to do cot x to the power 10x and you have to add it. So this e to the power log, and just write this one, cot x to the power 10x, and 10x will come in front. So it will be e to the power 10x log cot x. E to the power 10x log cot x. So differentiation of this will be this only. Same thing, e to the power anything will be e to the power that thing only. Then we have to do the inside one. So let us do the inside one now. So e to the power 10x log cot x. This same thing will come when we differentiate it. And then we have 10x log cot x will be 1 by cot x, and cot x will be what? Cot x, the differentiation of cot x is what? It's minus cosec square x, minus cosec square x. Now this log cot x we have to take outside. Differentiation of 10x will be sec square x. Now this 10x cosec square x cot x, let us see what do we get. Sine by cos, 1 by sine square. This is cos by sine. So this sine cos, sine square gets cancelled. 1 by cos square will go up. It will be sec square. So what do you get here? You will get sec square x. And you see the second term also contains sec square x. This is from where did we get cot x to the power 10x? So you can write it as cot x to the power 10x. Then we have sec square x, you can just take common. Only this, since we have a negative, okay, minus cosec square it came. So now log cot x will be here and this negative here, and then we can just write 1 because we already taken sec square x common. This is 1, this is 2, and just add these two and you will get the final answer. Okay. Now dy by dx, y is equal to sin x to the power x and sin inverse under root x. So let us see, sin inverse root x can be done directly. Sin x to the power x we have already done. It was e to the power log, just write sin x to the power x in front of that log. X will come in front. So e to the power x log sin x, that we have to differentiate. Let us differentiate this one first. So e to the power x log, dy by dx we are doing this one. E to the power x log sin x. Okay. So e to the power x log sin x will be that thing only. Then x log sin x will be x log sin x 1 by sin x will be cos x. And then we have a plus log sin x, d by dx of x will be 1. D by dx of x is 1. So e to the power x log sin x, and this was essentially sin x to the power x only. So sin x to the power x, you can write it here. Now x, cos x by sin x is what? It is cot x. So this is cot x. And you have log sin x here. This is your first part. First part is already done. What about the second part? Sin inverse under root x. So sin x under root x, I am doing it with a different color. This is you have to add to the first part. So sin inverse under root x can be done directly. So sin inverse under root x or sin inverse of anything will be 1 by under root 1 minus that thing square. So 1 root x whole square will be 1. X. So 1 by under root 1 minus x, and root x differentiation is 1 by twice of under root x. So 1 by twice of under root 1 minus x into x is, you can multiply inside x minus x square. If you multiply x with 1 minus x, it will be x minus x square. Final will be 1 divided by twice of under root x minus x square. This is the second part. First and second you have to add. This is the second part, and you will get the answer finally. Now dy by dx, this is x to the power cos x and sin x to the power tan x. We'll do the first one first. So you can just write it as e to the power log and then x to the power cos x. So x to the power cos x here. So e to the power cos x comes in front. So cos x log x it is. So it will be e to the power cos x log x. Differentiation of this, first one I am doing, okay. So d by dx of this e to the power cos x log x. So it will be this, it will be the same. And then cos log x. So cos log x will be 1 by x. Then you can take log x here. and cos x will be minus sin x. So let us write like this. This is the first part already done. Alright, first part is already done. So this came from x to the power cos x, e to the power cos x log x. I am writing it as x to the power cos x by cos x minus sin log x. This is your first part. Alright, then we have the 1 and 2 we are going to add. The second part I am doing now. Let us take the second part. It's e to the power log x, and you can write this log sin x. Log sin x to the power 10x, 10x will come in front, e to the power 10x and log sin x. Alright, now d by dx I am doing this one, so e to the power anything will be e to the power that thing only. So e to the power 10x log sin x, that same thing, and it has come from sin x to the power 10x. So just write it as sin x to the power 10x. Same thing, because these are the same thing, you know. So sin x, I'm just reducing the steps. Sin x to the power 10x, and then we have 10x here, and this was sin x, and then cos x, plus, and then log sin x we are taking outside, 10x will be sec square x. So sec square x log sin x. Okay, so this tan x sin by cos will be cos, and sin this all gets cancelled, so only 1 will remain. 1 plus sec square x and log sin x. 1 plus sec square x log sin x, and sin x to the power 10x will be outside. This is the second part or second term. 1 and 2 you have to add, and that will be the final result. Alright. Now dy by dx of y is equal to x to the power x plus sin x to the power x. So same thing you have to do. These individual term you have already done. So e to the power log x to the power x come in front, e to the power x log x, and then sin x to the power x, e to the power log sin x to the power x. It will be the e to the power x log sin x. Okay, let us differentiate them one by one. So this sin x to the power x already done, so I am not doing it again. We have already done in question number 28. This part x to the power, this sin x to the power x. See, let me tell you the answer also. This already we have done, so I am not doing it. Just one question back we have done. X to the power x already we have done, but we'll just try. We'll try to solve this. So e to the power x log x. So x log x is 1 by x plus log x. Differentiation of x is 1. So 1 plus log x it will be. E to the power x log x was essentially x to the power x only. So x to the power x, this will be. So these two terms you have to just add. Alright. Now 10x to the power log x plus cos square pi by 4. This is y. Now what do you see here? What will be the differentiation of cos square pi by 4? Pi by 4? Cos pi by 4 is cos 45 degree. This is 1 by root 2. 1 by root 2 whole square is 1 by 2. This is a constant. Constant differentiation is 0. So you don't have to worry about anything. It is 0 only, right? So this is a constant. Cos square pi by 4 is a constant term. So even if you differentiate, it is going to give you 0. So this is 0. So we just have to do 10x to the power log x. That you have to concentrate. E to the power log, and write this 10x to the power log x, and log x will come in front. So log x will come in front. It will be here. E to the power log x, this log x, log 10x. D by dx we are doing of this term. So it will be same thing. E to the power log x and log 10x, and that is nothing but 10x to the power log x only. That is 10x to the power log x only. Log x 1 by 10x. 10x is sec square x, and then plus this log 10x 1 by x. So this sec square x by 10x, it will be like that only. You know? Sec square x by 10x, 1 by cos square, sin by cos, cos by sin, cancel 1 by sin and cos. We will not get anything out of it. Okay. So better is to just write it like that. And what is this e to the power log x, this log 10x? It was actually 10x to the power log x, okay? So 10x to the power log x, sec square x by 10x log x, plus this is log 10x by x. Now you see this is the final result. Same thing. This will be 0. Cos square 4 pi by 4 is 0. Now dy by dx of y equals x to the power x plus x to the power 1 by x. So as I just said that these are repeated questions. If you want to just go ahead, you can just go forward. But who wants to understand? X to the power x will be e to the power log x to the power x come in front. So e to the power x log x, dy by dx of e to the power x log x will be remaining the same. E to the power x log x log x will be 1 by x, and then plus log x, differentiation of x will be 1. So e to the power x log x, it is coming from x to the power x only, and 1 plus log x. This is your first part. Then you have the second part, x to the power 1 by x. So first part you have already seen. Second part we are doing. So e to the power log, then x into 1 to the power 1 by x. So e to the power 1 by x will come in front, log x, dy by dx of this one. So this will remain same, e to the power anything will be e to the power that thing only. So we are doing the differentiation, and it will be, first term will be x to the power 1 by x only, because same thing. And 1 by x log x will be 1 by x, log x will be 1 by x. And then why I am taking minus, because you will just see. Log x, differentiation of 1 by x is minus 1 by x square. So minus, that is why we have taken. So log x by x square. So x 1 by x square it is. 1 by x square minus log x by x square. So you can take x square in the denominator. 1 minus log x by x square. This is your final answer. So this is 2 and 1. You can just add these two, and this is going to be the result finally. X to the power log x plus log x to the power x. So the scenario is same. The way is same. You can take it as u and v. You can take it as e to the power log, whichever you want. So we'll do it by taking u and v. So dy by dx will be equal to du by dx plus dv by dx. U is x to the power log x. So log u will be, log x will come in front, log x, log x, log x, log x. 2 log x will be there. And log x into log x is what? Log x whole square. So rather than doing by the product rule, it is better always to use it like log x whole square. So 1 by u du by dx, log x 1 by x plus, it is square, so this is one way. Okay, log x 1 by x, again 1 by x log 1 by x log x, so that is going to be twice of log x by x, same thing, right? So what we'll do here is log x whole square it is. So twice of log x will be 1 by x. So here we have log x whole square, just assume to be log x whole square. Twice of log x will be 1 by x. So twice of log x by x is the result here, but you have to take u also on that side. It is x to the power log x. So x to the power log x into 2 into log x divided by x is your final result for the first part. Alright. Now let us take the second part. The second part is this log x to the power x. And this is the first part I am showing you. Then we have the second part. I am changing the color. So v is actually log x to the power x. So log v will be x log of log x. X log of log x. This is 1 by v dv by dx is equal to, now differentiation of this. So x log of log x will be 1 by log x, and log x will be 1 by x. So this x gets cancelled, you have 1 by log x plus log x, and differentiation of x will be 1. So what do you get finally? 1 by log x plus log of log x. 1 by log x plus log of log x, and this v has to be taken on the right hand side. I hope you got the idea. This v has to be taken on the right hand side. dv by dx will be equal to v on the right hand side, which is log x to the power x. And this is your second part. The first part, second part you can just add, and you can say, oh, this is the answer. 1 and 2 you can just add. Now in this question, what we have to do? This is dy by dx equals to y by x that we have to prove. So the best way is to take the logarithmic way of derivation. So x to the power 13, y to the power 7 is equal to x plus y to the power 20. Let us take log on both the sides. Please remember, log a into b is log a plus log b. So we can write this as log x to the power 13 plus log y to the power 7. Here also we can take log. So 20 will come in front. So this 13 will come in front, 7 will come in front, and this 20 will come in front, 20 log x plus y. Now let us differentiate both the sides. So d by dx of both the sides will be 13. Log x is 1 by x plus 7. Log y is 1 by y, then dy by dx. So this is dy by dx also is equal to 20 log x plus y. So 1 by x plus y, differentiation of x plus y will be 1 plus dy by dx. So you can write this as 1 plus dy by dx. Now the only thing is dy by dx on one side, other things on other side, and that will be your result. You will get y by x finally. Okay, so what we'll do is I am multiplying 20 by x plus y with the inside one, that is 1 and dy by dx. So this is 13 by x plus 7 by y dy by dx equals 20 into 1 by x plus y. So that will be 20 into x. 1 will be 1 only. So 20 by x plus y. And then 20 into x plus y into dy by dx. Okay, let us take this dy by dx on one side and others on other side. So I am taking this on the left hand side. So this 7 by y. This dy by dx I am taking common. So inside one will be 7 by y minus 20 by x plus y. And then this 20 by x plus y is here, and 13 by x I am taking on the right hand side. So let us bring it here. Minus 13 by x. Now let us solve this. We know how to take the LCM. So the best way is, let us take the LCM now. Dy by dx will be on the left hand side. So this is y into x plus y. First you multiply this, put it in the denominator, then you cross multiplication 7 into x plus y minus y into 20y, that is 20y. Here also 20 into x minus 13 into x plus y, and in the denominator it will be x into x plus y. And dy by dx is already there on the left hand side. Okay, x plus y, you can cancel these two out. And what is remaining is x and y in the denominator on either side. So dy by dx. Now let us see what is there in the numerator, because it has to cancel out. We don't have anything on the answer. So 7x plus 7y minus 20y will be 7x. 7y minus 20y is minus 13y. So this is going to be 7x minus 30y. Here on the right hand side we have 20x minus 13x minus 13y. So 20x minus 13x will be 7x. 7x minus 13y. Now what do you see here? On the left and right, both the numerator are exactly the same. So you can just cancel these two out. So dy by dx on the left, dy by dx left. On the right you have y, you have to bring it in the numerator, x will remain in the denominator. So all these cancels out. Only the thing remaining is dy by dx is equal to y by x. Now x to almost similar kind of question this is. X raised 16, y raised 9, and x square plus y to the power 17. So we'll try to do it in a way of shorthand. Both sides log and differentiate. Dy by dx on one side, others on other side. Okay. So we have log x to the power 16, y to the power 9, and x square plus y to the power 17 with the log. Now the power will come in front, but log a into log a into b is log a plus log b. So log x to the power 16. 16 will come in front, so I am writing it here only. Plus log y to the power 9. And I know 9 will come in front, so let us write like that. 9 log y. This is equal to 17 will come in front. 17 log x square plus y. So log x square plus y. Okay. Now we have to differentiate each and every term here. Dy by dx I am doing for every term. 16 log x is 1 by x plus 9 log y is 1 by y. Dy by dx also is equal to, because we are differentiating with respect to x, 17 log, so it will be 1 by x square plus y, and differentiation of x square plus y will be 2x plus y divided by dx. So you have 2x plus twice of x plus dy by dx. Okay, now let us multiply inside on the right hand side, and then we have to bring dy by dx terms together, others on other side. So 16 by x it is. I am multiplying and then bringing it on the left hand side. Okay, 17 into 2 is 34, 34x divided by x square plus y, that is going to be brought on the left hand side. So 34x by 17 into 2x is 34x by x square plus y. And now let us multiply first with the dy by dx term. So 17 by x square plus 4 into dy by dx, and now bringing 9 by y dy by dx on the right hand side. So minus 9 by y dy by dx. So let us solve this. 16 into x square plus y minus 34 into x square divided by x into x square plus y. On the right it will be dy by dx. Let us take it common. I am taking it common. Okay, 17 into y minus 9 into x square plus y and divided by y into x square plus y. So dy by dx we have already taken common. So what do we get? X square plus y gets cancelled. X and y it is. So this is going to be, you need some twice here. X divided by dx is equal to 2y. That is what you want. So let us solve the numerator first. And 16x square plus 16y minus 34x square in the numerator. And of course x in this 16y, this 16 minus 34, 16 minus 34. So this, let us subtract these two. So you have 8, here 18. So 18x square it will be. And this is divided by x. On the right it is dy by dx. 17y minus 9x square minus 9y. So let us do it here only. 17y minus 9x square minus 9y. 17 minus 9y is going to be, so it will be 8y. And 8y minus 9x square. Now what do you get in the numerator? 8y minus 9x square. And this is nothing but 2 into 8y minus 9x square, which is actually 16y minus 18x square. So if you take 2 common from the numerator on the left hand side, it is twice of 8y minus 9x square divided by x divided by dx. 8y minus 9x square divided by y. The numerator gets cancelled because we have 8y minus 9x square here. 2 by x here divided by dx with y. So let us do it. Dy by dx is equal to, so you have x on x, you have to bring it here, and then twice y on the right hand side. Just write it as twice of y. Alright, that's your answer. Okay. So this question, y is equal to sine x to the power x. Okay. So we have to prove that this dy by dx is this expression. So we have to reach till here. Alright. So we have to put something or assume something so that we get a proper easy answer. Sin x to the power x it is. So you have log y equals x log sin x. So will it be okay to do that? We can have one more aspect here. Means, see, in order to solve this, if we can make it more easier. So rather than taking this kind of stuff, we can do one thing. The best way is to take x to the power x as something. That will make it easier. So same thing we'll try to apply here. X to the power x will take something. Rather than taking sin x to the power x as y, I am taking x to the power x some u or v. Now when you have this y equals sine, and then x to the power x is already taken as u, so y is equal to sine u. That we are going to use later. But x to the power x is equal to u, this one I am differentiating, then we'll put it later. So u is x to the power x, log u will be x log x. So this is 1 by u du by dx is equal to x plus log x is 1 plus log x. We have done it many a times. So u by dx is equal to, if u I am taking on the right hand side, which was essentially x to the power x only, and then 1 plus log x. Now coming back to what we have seen here. So we have dy by dx equals, sin u will be cos u, it will be cos u. And since this cos u, we have to do du by dx also. Cos u we have done, but it has to be du by dx also. So now in place of u, replace it by x to the power x. So cos x to the power x, and in place of du by dx, just place this one, x to the power x, 1 plus log x. So what do we get? Cos x to the power x to the power x, and 1 plus log x. Now if x to the power x plus y to the power x is equal to 1, we have to prove this. Dy by dx is equal to this one. So this will be essentially all rearrangement. Please remember. You can assume it to be u and v, du by dx, dv by dx. You can just add them. The same thing will come. There is no special thing here. The shorthand method I already told you. So e to the power log of anything, log base e, it's equal to 1. So e to the power log you can write anytime. And then in place of this x to the power x can be placed here. E to the power log can be written. Now x to the power x it is. Now x to the power x. So we have log a to the power will be b is b log a. We already know that. So e to the power x log x. And then we have e to the power log, again y to the power x will come in front. So I know that this x is going to come in front. So I'm doing it shorthandly. So d by dx we are going to do now. So e to the power x log x will remain like that, d by dx. Now d by dx of x log x will be done. X log x was 1 plus log x. We have just done it, and we have done it several times. And e to the power x log y will be e to the power x log y. Then x log y will be, see, x log y, I'm doing it here. X log y is 1 by y dy by dx. Then we have log y, and d by dx of x is going to be 1. So we have x by y dy by dx plus log y. So we have x by y dy by dx plus log y. On the right it will be 0 because d by dx of 1 is 0. So same thing, from where we started we can write that like that. E to the power x log x is nothing but x to the power x, 1 plus log x. Then we have to add with e to the power x log y. And e to the power x log y was essentially y to the power x only. And x by y dy by dx plus log y. And then we have this on the right hand side is going to be 0. So only thing is to multiply every content and then take the dy by dx separately and others on the other side. So we have, there is now just a rearrangement. Okay, you can just skip if you want to because there is nothing more left. We have already done it. It's just rearrangement. So d by dx of 1 is 0. So I am taking every term, the second term on the right hand side. So x to the power x, 1 plus log x, and other term on the right hand side. It will be negative. So minus y to the power x, and inside this we have x. So I'm multiplying it inside, y to the power x into x by y into dy by dx. Then y to the power x again multiplied inside log y. Okay. So this is dy by dx I have to take on one side. So that is whatever is there without dy by dx I'm bringing it on the left hand side. So x to the power x 1 plus log x. Since it was negative on the right hand, it goes positive on left. So y to the power x log y, I have got it here, and negative y to the power x by y. So it is y to the power x minus 1. So you can write it as y to the power x minus 1. Then we have x also. So x into y to the power x minus 1 dy by dx. Now just take everything except dy by dx on left hand side or right hand side, whichever you want. So x, y to the power x minus 1, I am bringing it here with a negative sign. So what did you get? This one, this thing. So it is multiplication. Okay. So let us do it now. The same thing, same way. Take log on both the side. So your log x to the power y multiplied by y to the power x is equal to log 1. Log 1 will talk later. Basically it's 0 only. But log a into b is log a plus log b. So you have log x by x to the power y. So y will come in front. Similarly, log y to the power x will come in front. So y log x plus x log y will be equal to 0. Log 1 is 0, but we will differentiate the constant and make it as 0. So y log x differentiation is y by x, then plus log x dy by dx. Dy by dx plus now x log y. Differentiate x log y. So we have x log y is 1 by y plus log y. X is dy by dx of x is 1. So dy by dx is 1 only. So you have to bring everything on the right hand side except dy by dx. Because there is one dy by dx also, I'll just do it. Okay, there will be one dy by dx. See here, dy by dx. Because we are differentiating with respect to x, not y. So this is y log x is 1 by x plus log x dy by dx. Here x log y is 1 by y and then dy by dx. Plus log y dy by dx of x is 1. Okay. Let us combine them now. So everything with dy by dx on one side, others on other side. So I'm taking everything on right hand side without dy by dx, so minus y by x here and plus log y. And on the left hand side we have dy by dx. It has to be taken outside. So log x plus x by y. Now just solve this. Y log x plus x divided by y dy by dx is equal to negative of y plus x log y divided by x. Okay, now the simplest thing is dy by dx on one side and others on the other side. So dy by dx will be equal to minus y into x plus y plus x log y. X is already there. So we have y log x plus x. Okay. Dy by dx is this one. So this is your final answer. Okay. X to the power y plus y to the power x is equal to x plus y to the power x plus y. We have to find the dy by dx differentiated. So since it is of the type of x to the power gx, so we can do it using the log. And this is a short form also. I told you already that e to the power log, you can always write anything in front of that, that is in the power. So e to the power log x to the power y will come in front. So we can write this x to the power y as e to the power y log x plus same here e to the power log y to the power x. So x will come in front. So it will be e to the power x log y. Alright, then we have the right hand side, but we'll do it later. First we'll complete the left hand side. So let us differentiate it now. And dy by dx we are doing for the left hand side. So e to the power anything will be e to the power that thing only. So e to the power log x and then y log x differentiation. So y and log x differentiation is 1 by x, then log x and dy by dx. Then coming to e to the power x log y, differentiation of e to the power anything will be e to the power that thing only, e to the power x log y. Then now x log y is 1 by y, then dy by dx. Then we have log y and dy by dx of x is 1. Alright. So this has come from where? X to the power y, it is actually equal to that only. And e to the power log y to the power x is y to the power x only. So x to the power y and y by x, I am multiplying inside. So x to the power y into log x dy by dx plus. Now this is y to the power x only. This you can write it as y to the power x. So you can multiply y to the power x inside. So yx into x by y dy by dx plus the yx, where is x, log y. Alright. Now we'll take dy by dx term together and other term together. So x to the power y by x can be written as x to the power y multiplied by x to the power minus 1. So it will be x to the power y minus 1. So this is x to the power y minus 1. And there will be y also. Y will be there. And then we have y to the power x log y. So this is y also. Let me write it also. Y to the power x log y. Okay, these are the two terms without dy by dx. I am now writing the dy by dx term. So dy by dx I am taking common. So it will be x to the power y log x plus, now y to the power x by y in the same manner. It will be y to the power x minus 1 into x. Alright. So on the left hand side, the things will go on the right hand side. So on the right it will be minus x to the power y minus 1 into y and minus y to the power x log y. Whenever we'll take it on the right hand side, the first two term you'll find it in negative. I'll show you. And this, whatever is inside dy by dx, that will go in the denominator. Alright. Because there is going to be dy by dx from right hand side also. Now coming to x plus y to the power x plus y, we can write it as e to the power log x plus y to the power x plus y will come in front. So it will be e to the power x plus y log x plus y. And now differentiating it, I am taking the right hand side. So when we differentiate it, it will be same thing, e to the power x plus y log x plus y. And since it was already equal to x plus y to the power x plus y, I am changing it also. Now we'll differentiate this one. So x plus y log x plus y will be 1 by x plus y, and differentiation of x plus y will be 1 plus dy by dx. So it will be 1 plus dy by dx only, because x plus y by x plus y will get cancelled. Now this is the first term. So first term is simply 1 plus dy by dx. Now we will take log x plus y outside and then we'll differentiate x plus y. So what do we get? X plus y to the power x plus y. 1 plus dy by dx, this is the first term. And now we'll take log x plus y outside plus log x plus y. This is going to be outside. And x plus y differentiation will also be done. X plus y differentiation will be 1 plus dy by dx. So let us write it as 1 plus dy by dx. Now you can take log x plus y common and you will get 1 plus dy by dx inside. So it will be, or you can take 1 plus dy by dx common. That also you can do, but we will multiply everything. So x plus y to the power x plus y. And I am multiplying it first. Log x plus y plus log x plus y into dy by dx. Since I am multiplying x plus y to the power x plus y inside, I have already multiplied whatever was inside. So why I am doing it? So let us multiply this. I am multiplying now the outer term with the inner term. So first term will be the same, x plus y raised x plus y. Then we have dy by dx. So it will be x plus y to the power x plus y dy by dx. And there will be 2 dy by dx here. So we have to add this 1 plus dy by dx plus log, I am just cancelling it because it is 1 plus dy by dx plus log x plus y plus log x plus y dy by dx. So let us multiply now. So now multiplied, now x plus y to the power x plus y dy by dx. And then plus x plus y to the power x plus y log x plus y. And then plus x plus y to the power x plus y log x plus y plus dy by dx. Alright. Now this dy by dx will take one side, means together. So dy by dx I am taking, and now you can take this x plus y to the power x plus y also common. You will get 1 plus log x plus y inside. What I am saying is x plus y to the power x plus y, and then x plus y to the power x plus y log x plus y is inside. So once you take x plus y to the power x plus y outside, it will be dy by dx into 1 plus log x plus y. The other term remaining is these two terms which I am writing right now. So these are the remaining term. Now we are short of space, so just see very left hand side, right hand side. Okay, I hope you have got the idea what is left hand side or right hand side. So now you see these two terms you will see on the right with negative. I told you. So this x to the power y minus 1 into x into y. This is the first term. Then y to the power x log y in the negative because it will go on the right hand side. This is the second term. And what is remaining? Here x plus y to the power x plus y. And here you can take x plus y to the power x plus y common. You will get 1 plus log x plus y inside. So 1 plus log x plus y. Okay, this term, this is without dy by dx. So this is the third term which I just wrote. Okay. So the numerator you got, because other terms in the denominator will be right hand. See these two terms, x to the power y log x here, then x y to the power x minus 1 here, and these two are on the left. So it will go on the minus on the right hand side in the denominator. So x plus y to the power x plus y you can take common. So only 1 plus log x plus y will remain inside. So if I take common x plus y to the power x plus y, 1 plus log x plus y will remain. So this is what we have taken common, 1 plus log x plus y inside. So I hope you got the idea. So I want you to be very clear about the answer. So I want to show you. Let me clear it. So this is the final answer. It is just rearrangement. X to the power m, y to the power m multiplied is equal to 1. So dy by dx has to be equal to minus my by nx. Now let us see. So we'll take a log. That is the best option for us. And log a into b is log a plus log b. So I'm taking log on both the side. Log x to the power m into y to the power m n is equal to log 1. Now log a into b. So log a plus log b we'll write. So log x to the power m plus log y to the power n is equal to log 1. So this will come in front. So it will be m log x plus n log y. M log x plus n log y is equal to this log 1. We'll do it. Let us differentiate both the sides. M will be constant. Log x is 1 by x plus n. Log y is 1 by y. Dy by dx is equal to d by dx of log 1. That is a constant value. It is going to be 0. Dy by dx on one side, other things on the other side. So we have n by y. Dy by dx equals to, this goes on the right hand side. It will be negative m by x. Now y goes up, n goes down. And this dy by dx is going to be equal to minus m by n, x by y. Y by x. Alright. Now this question, we'll do it using a log. But there is just one step which is the basis of this question. So I'm taking log x log y equals y minus x log e. And log e, base e is 1. So x log y equals y minus x. I don't have to write log e now. Okay, now let us differentiate both the sides. So I'm going to use this in the later part. So you have to be very careful about what I'm going to do with the left hand side. Means the left partition which I'm showing. I'm differentiating it now. X log y is 1 by y, dy by dx plus log y here. And dy by dx of x is going to be 1. Is equal to y is dy by dx and minus differentiation of x is going to be 1. So dy by dx on one side. So we have x by y dy by dx minus dy by dx. This comes here is equal to negative 1 negative log y. So dy by dx has to be taken outside. We'll get x by y minus 1. And on the right hand side you can take minus common, 1 plus log y it will be. Alright. Now you see here x log y is equal to what? Y minus m. Now let us take the x term together. So it will be x log y plus x. I am taking x on the left hand side equals y. Let us take x common. So 1 plus log y it will be y. So x term on one side, y term on other side. Or you can say x by y is equal to 1 by 1 plus log y. Alright. So this x by y we will replace, because there is no x term in the answer. So you have to replace x. You can also write x as y by 1 plus log y. That is also you can write, but y gets cancelled. So I have just written x by y. dy by dx, x by y, in place of that I am writing 1 plus log y minus 1. And here you have minus 1 plus log y. So let us take LCM here. 1 minus 1 minus log y divided by 1 plus log y. And we have dy by dx. So this goes on the right hand side. 1 gets cancelled. So minus 1 plus log y, denominator also 1 plus log y, so it will be 1 plus log y square. So minus gets cancelled because it is negative on the left hand side also. So 1 plus log y whole square, and log y will come in the denominator. This is how you have to do it. You just have to take care of the left hand side, what we have done. Replacement actually. Now sin x to the power y is equal to cos y to the power x. So dy by dx. So I'll try to do it in a shortened form, because all this we have done in the earlier part of this exercise. I'm taking log on both the sides, so it will be y log sin x equals x log cos y. Y will come in front, here x will come in front. Okay, let's differentiate. Y log sin x will be 1 by sin x, and sin x will be cos x. And then we have, then log sin x will take outside, and then we will differentiate y. So log sin x dy by dx we have to do. Now is equal to x log cos y. So log cos y will be 1 by cos y and minus sin y of, because cos y has to be done already, plus log cos y. Now dy by dx of x is going to be 1. And then dy by dx, there will be 1 dy by dx also, where it will be, I'll just do that because this, the right hand side first term has to have a dy by dx. I'll just do it. So log sin x, this minus will come in front, plus sin y by cos y is tan y. So this is x, sin y by cos y is tan y, dy by dx. So dy by dx I'm taking outside and taking on the left. So sin by cos is tan. So x tan y you can write. And what else is remaining? Log cos y is remaining. And this is cos by sin. This is cot. So cot x, y cot x. Y cot x has to be taken on the right hand side. Minus y cot x. Now it's just divided. So it will be log cos y minus cot x, y cot x divided by log sin x plus x tan y. Alright. And almost similar question. So we'll just differentiate both the sides. So it will be cos x to the power y equals tan y to the power x, taking log on both the sides. When you take log on the side, y will come in front, y log cos x plus is equal to x log tan y. Now differentiate this. Y log cos x will be 1 by cos x, and cos x will be minus sin x, negative sin x. Then we have log cos x and then dy by dx. Okay, on the right it will be x log tan y will be 1 by tan y, and tan y will be sec square y. Sec square y. And then dy by dx. Y is there, so dy by dx plus log tan y dy by dx of x will be 1. So I am applying the product rule, remember. Now dy by dx, take on one side and take dy by dx common. So dy by dx common, log cos x and minus, this is, what do we get from here? X is already there. Sec square is 1 by cos square, and this is tan y sin by cos. Cos goes up, cos by sin, cos gets cancelled. So 1 by cos sin, so when cos sin goes up, it will be sec and cosec. So what you will get? X sec y cosec y. So just write it here. X sec y cosec y. These are the dy by dx term. What are the other terms? Log tan y here, log tan y. And since it is negative on the left hand side, So let me write it here. Y minus y sine by cos is tan. Sine by cos is tan. So I have to make it as y. It is tan. I'll just change it. So y tan. Since it is negative, it will go on the right hand side. It will become positive. Y tan x. Now this will be the denominator. It will be log cos x minus x sec y cosec y. So log cos x minus x sec y cosec y. This is in the denominator. All right. So this is numerator. This is denominator, which you see here also. Numerator and denominator. All right. Now we have e raise x plus e raise y equals e raise x plus y. So we have to prove this. So we will just differentiate both the sides. And there is only one catch here, one thing which has to be done. So let us differentiate here on both the sides. So we have, e to the power anything, differentiation will be same. So e to the power x, here e to the power y. But we are differentiating with respect to x, so it will be dy by dx. Again here e to the power x plus y, and then differentiation of x plus y, so 1 plus dy by dx. So just multiply this e raise x plus y inside and combine the dy by dx terms together. So e to the power x, e to the power y, dy by dx. On the right, it is going to be e to the power x plus y into 1 plus e raised x plus y into dy by dx. Okay, now bring this here. Whichever way you want to take, just you have to take dy by dx on one side and else other remaining on other side. So e to the power x minus e to the power x plus y. And on the left hand side, what you can do? Dy by dx you can take common. And then we have e to the power x plus y minus e to the power y. So this dy by dx will be, whatever is with dy by dx will go in the denominator. So e raise x minus e raise x plus y divided by e raise y minus e raise x plus y. No. Just swap these. So e to the power x plus y minus e to the power y. Now the question is already given to you, and since there can be a replacement, in place of e raise x plus y, you can just write ex plus ey. That is e raise x minus this. In this place you can write e raise x plus e raise y, and divided by, you have e raise x plus e raise y minus e raise y. This is the only thing which you have to do. Other things you already know. So e raise x minus e raise x minus e raise y, then ex, ey minus ey. This gets cancelled, these two gets cancelled. There is a negative here. So it will be negative e raise y by e raise x, dy by dx on one side. So just assume that this e raise y by e raise x, when it goes up, it will be e raise y minus x. And we have dy by dx. So bring it here now. So dy by dx plus e to the power y minus x is equal to 0. Now this is the only catch, okay? Replacement. Now ey equals yx. So we have to differentiate this. Now this kind of question, since we have done almost 44 questions now, so this question you have already seen. So what we'll do here is we'll just take a log on both the sides. So when we take the log, the power will come in front. That is y log. And since log e, that is log e is going to be 1. Log e base e is 1. So y, I am replacing the log or removing the log. So y is equal to x log y. So x, you can write it as y by log y. Since on the right there is no x, that is why we have done this. On the right there is no x, so you need a replacement of x somewhere. So now I am taking this one and differentiating this one. So dy by dx is equal to, so x log y is 1 by y plus and then dy by dx also, plus log y, and then dy by dx of x will be 1. So dy by dx, and what we can do here is we can bring this here, x by y dy by dx on one side. So x by y dy by dx on one side, log y on another side. So dy by dx, when you take common, it will be 1 minus x by y, and this is going to be equal to log y. So when we solve this, it's going to be, I'm taking the LCM, y minus x by y, and I'm taking this on the right hand side also. Alright, so it will be dy by dx equal log y into y divided by y minus x. I have taken this on the right. So we have log y into y divided by y minus x. So now this log y log y minus, in place of x, what you can do here is put y by log y. Now you can just take y common from here. So log y by, so 1 minus 1 by log y, and then we have log y minus 1 by log y. This is in the denominator. So log y was already there. This will go up, so it will be log square, and log y minus 1 will be in the denominator. So log y minus 1 here. Okay, this is your final one. So this one, you can do it by yourself. It's quite easy. Those who want some assistance, I'm going to tell them e to the power x plus y equals x. We are taking x on the right hand side, and now just differentiate. E raised x plus y will be same. X plus y will be 1 plus dy by dx. dy by dx of x will be 1. So now multiply, and please remember this e to the power x plus y was what? It is x only. E to the power x plus y is x only, so you can replace this by x. So x 1 plus dy by dx is equal to 1. This x on the denominator, so 1 plus dy by dx is equal to 1 by x. Now dy by dx will be what? 1 by x minus 1. So dy by dx is 1 by x minus 1. It will be 1 minus x by x. 1 minus x by x, dy by dx here. Okay. Now y is equal to x sine a plus y. And dy by dx, the main key thing here is there is no x on the right hand side. So it is quite easy and understandable that you need somewhere replacement. So x will be equal to y by sine a plus y, that you get from the first equation. So we are going to replace this x somewhere. Okay, and we'll first differentiate, and wherever we get x, we'll replace it by this thing. So dy by dx is equal to x sine a plus y, so x sine a plus y is cos a plus y. Then differentiation of a plus y. This is going to be a is 0 and y is dy by dx. And then we have sine a plus y here. Dy by dx of x will be equal to 1. Okay. So 1 dy by dx is here. You can bring it here. Take dy by dx together. So I am taking it here, making the sign minus and equal to on that side. So dy by dx you can take common. You will get 1 minus x cos a plus y. And this is what we'll get. On the right it is sine a plus y. Now I am bringing the left stuff to the denominator of right stuff. Sine a plus y divided by 1 minus x cos a plus y. In place of x, now I am replacing it by y by sine a plus y. So sine a plus y divided by 1 minus x in place of x. Just write y by sine a plus y. Alright. And we have cos a plus y. So what do you get? You get, I'm talking about denominator now. So sine a plus y minus y cos a plus y, and it is divided by sine a plus y, that goes up. So it will be sine square a plus y. It goes up, sine square a plus y. So dy by dx will be this one. Now what is this? This is what we wanted. Now you have x sine a plus y plus sine a cos a plus y is equal to 0. Now here also you see there is no x on the right hand side. Alright. So you have to take the x from the first equation and then find out whatever is x on the left and whichever thing you get on the right. So assume a plus y as theta. So x sine theta plus sine a cos theta is equal to 1. X sine theta is equal to minus sine a cos theta. And this sine theta will go down. Basically it will be sine a cos theta was a plus y. So sine a cos a plus y divided by sine a plus y. That's what we are going to replace any moment wherever we want after differentiation but. Alright. So let us differentiate this equation. You know already how to do this. The first one, there will be a differentiation with product rule. The second one, it's only sine a is constant, so it will be only differentiation of cos a plus y. So x sine a plus y will be cos a plus y. Now a plus y differentiation will be a will be 0, y will be dy by dx. So only dy by dx will come. Plus. Now there is one more thing remaining, but let me do it sine a 1. Sine a I am taking outside. Cos a plus y will be minus sine a plus y. So cos a plus y will be minus sine a plus y. See, I have not completed the product rule. Please understand. I am just doing the second one first. Sine a and then cos a plus y is minus sine a plus y, and there will be dy by dx also. Because it is a plus y. So there will be dy by dx also. Okay. Now one more thing, that is one more product rule thing is remaining, which is taking sine a plus y outside and then differentiating it with us, x. So it will be only sine a plus y. So x sine x cos a plus y dy by dx, and this I am writing it here now. Okay, just assume that it is here. So what we have done is x cos a plus y dy by dx. Now sin a plus y will take outside, dy by dx of x will be 1. And this we have already done. So we have 2 dy by dx. Let us take dy by dx common first. So you have cos x cos a plus y, this one. Here now minus sin a plus y. And on the right, this goes on the right. Sin a plus y goes on the right. Minus sin a plus y. And I already told you I don't like the negative like that, so I will swap these values. So this minus sin a plus y. If I want to replace this negative, I have to exchange or swap the position of left side 2 terms. It will be sin a plus y divided by sin a plus y minus x cos a plus y. Okay. Now dy by dx we have already got, but the problem is that this is not the final answer because x has to be replaced by something which will only get you y. So in the beginning I told you this x is basically minus sin a cos a plus y divided by sin a plus y. So sin a plus y, I am telling you the denominator now. So sin a plus y plus minus plus, so sin a cos a plus y divided by sin a plus y, and there will be a cos a plus y. So now I am showing you the denominator, and this is going to give you a very fruitful result that will match the answer. Alright. So we have sin a plus y plus sin a cos a plus y, and there is a, because sin a plus y in the denominator, cos square a plus y, because there are 2 cos now. Now I will take the LCM. Now multiply this. So we have sin a, denominator I am only telling you, okay. Sin a plus y, so it will be sin square a plus y, plus sin a cos a plus y, and divided by sin a plus y. Since it is in the denominator of a denominator, it will go in the numerator. It will be sin square a plus y. It will be sin square a plus y divided by, see, so what do you get? Sin a, if we take common, it will be sin square a plus y plus cos square a plus y. And sin square theta plus cos square theta is what? Or sin square a plus y plus cos square a plus y is what? It is going to be 1. So only sin a will remain in the denominator. So this is your final answer. Alright, this is your dy by dx. Next question. So we have sine x to the power y equals x plus y, and this is what you need to have in the right hand side of dy by dx. So we have this is the reference you can take if you want to do it by yourself. So first thing is just take the log. So assume that I have taken log, y will come in front. So y log sine x is equal to log x plus y. And now what we'll do? We'll do the differentiation. So dy by dx I am doing on both the sides. It will be y log sine x is 1 by sine x will be cos x, plus log sine x now outside, y will be dy by dx. And on the right hand side it is log, so 1 by x plus y. Differentiation of x plus y is going to be 1 plus dy by dx. And you know how to do this now, because dy by dx you have to take on one side, others on another side. So just multiply things. So y cos by sine is cot log sine x dy by dx. Now on the right you have to multiply inside. So 1 by x plus y plus dy by dx, that is 1 by x plus y into dy by dx. So 1 by x plus y dy by dx. So now bring this dy by dx on one side. Now you see what is shown in the answer. Just take things on that side so that you get the proper result. So dy by dx here, log sine x, and this we have taken now this one. So it will be minus 1 by x plus y into dy by dx, which we have already taken common, is equal to 1 by x plus y minus y cot x. Now solve this. Just take the LCM of both the sides. Take the final result and bring it on with the numerator denominator. So x plus y log sine x minus 1 divided by x plus y. This is on the left hand side with dy by dx. On the right you will get this 1 minus y cot x plus y also, and divided by x plus y. So now just cancel these two out in the denominator and just bring whatever is on the left in the denominator. So what do you get? This is numerator, this is denominator. The answer has come. Alright. Here we have x into y into log x plus y is equal to 1, and dy by dx has to be proved like this. So there will be a replacement. We'll talk about that. But before that, we have three terms here: x, y, log x plus y. There are three terms here. So when we differentiate it, we will keep two terms outside, and then we will differentiate the third term. That is the product rule with three terms. It can be n terms also. So x, y I have taken outside. Log x plus y differentiation is 1 by x plus y, and then differentiation of x plus y is 1 plus dy by dx. Plus, next is y and log x plus y outside, and then we have dy by dx of x, which is 1, which is going to be equal to 1, plus. So xy we have taken outside, x log x plus y, and now here we'll take y log x plus y. This time we will take x and log x plus y. Y already log x plus y we already done. So now this is dy by dx only, the third term, and is equal to differentiation of 1 is going to be 0. Now let us multiply inside. So we'll separate out the dy by dx terms. So xy by x plus y into xy by x plus y, then dy by dx, plus y log x plus y plus x log x plus y dy by dx. As I said, we will try to combine this dy by dx term. So this is going to be xy by x plus y, and here it is x log x plus y. Okay, the other terms which are not having dy by dx with them, we are taking it on the right hand side, so it will be negative xy by x plus y, this one, and then we have y log x plus y. Negative because it's on the right. We have taken it on the right. Okay. So there will be certain replacement here. See, log x plus y from the first equation, what it will be? Log x plus y will be equal to 1 by xy. So this log xy can be written as 1 by xy. So in this place, if I write 1 by xy, x will get cancelled. Okay. Only 1 by y will remain. So this is 1 by y. And then let us solve this first. So xy square plus x plus y into x plus y dy by dx here. This also. So this xy by x plus y plus y. Now in place of log x plus y, replace it by y and x by. So only 1 by x will remain. Because log x plus y we have taken from xy equals 1 by log x plus y. That is how we have replaced. So now we have x square y plus x plus y and then y x plus y. Now you can just get, no, this is x plus y. So I'll just change it. So in the numerator it will be x square y plus x plus y. In denominator this will come. So this I am taking into the denominator, xy square plus x plus y. And since we have x or y, see, the left term has y in the denominator, the right term has x in the denominator. I'll just change it. Okay, so you will get y by x in the right hand side. And since it was already a negative, when we started, in the middle of this, we have taken things on the right, and that was negative, so we'll take it on the right hand side. So y, see, x plus y from the denominator we cancelled, and y by x here, and this is negative. So minus y by x square y plus x plus y divided by xy square plus x plus y. Okay. So there is a cancellation thing which I just checked and written the proper way. Now here I'll show it to you here only, because differentiation of log will be 1 by that of thing. So this will come, the terms numerator denominator will change places. So this is the place I am highlighting. X square minus x plus 1 will be numerator and x square plus x plus 1 denominator. And then we will do the differentiation of this one inside log. So that will be through the quotient rule. Okay. The differentiation, x square minus x plus 1 square will be the denominator, and then proper quotient rule. So when you solve all of this, what do you get? So this is just algebra, okay. Differentiation is simply log is 1 by that thing, and then differentiation with quotient rule. Now this other term, 2 by under root 3, tan inverse root 3x by 1 minus x square. So 2 by root 3, 1 minus 1 by 1 plus x square. Tan inverse differentiation is 1 by 1 plus that thing square. So it is now the differentiation of this term, root 3x by 1 minus x square, differentiation of this term. And that will be of p by q quotient rule. So you know how to do this, okay. So final result will be like this of two terms. When you combine this will be 4 by 1 plus x square plus x to the power 4. Now this will take a lot of time if I actually do it. So I'll just tell you the logic. Log differentiation is 1 by x, p by q, and then whatever is inside in p by q quotient rule you have to apply. Second one also, tan inverse that thing, 1 by 1 plus that square thing, and then differentiation by quotient rule. Now we have y equals sin x minus cos x to the power sin x minus cos x, and there is a boundary or limit also given. So we have to find out the dy by dx. Okay, if we replace things, then the boundary will be checked. But here we'll just take the log, both the sides. So log y will be equal to, this will come in front, so sin x minus cos x, and then differentiation d by dx of sin x minus cos x. So we have, this has come in front, okay. Now there are two terms on the right, so we'll apply the product rule here. Let us differentiate both sides. 1 by y dy by dx is this y is whole of this. Okay, because we are going to keep it on the right just now. Sin x minus cos x, one term. Second term log sin x minus cos x. Let us differentiate it now. Okay, we'll apply the product rule. So we have sin minus cos. Log sin minus cos is 1 by sin minus cos. And then sin minus cos, so sin will be cos. And then cos will be minus sin. So plus sin it will be. Okay. Okay, this is plus. Now log sin minus cos will take outside and differentiation of sin x minus cos x. So sin minus cos will be cos minus of minus cos x will be sin x. So sin x will be cos x plus sin x. Same thing as the first one. So cos x plus sin x has come twice. And also in the first term, sin x minus cos x is in the numerator also, denominator also. So you can just cancel this out. And cos plus sin you can take outside. So let us take this outside, cos plus sin. What will be inside? 1 plus log sin x minus cos x. Now this C stands for cos, S for sin. And this y by 1 by y, what was y? This will go here. So sin minus cos to the power sin minus cos will go on the right. Okay. So this is the result. Same thing here. Or if you see here, if you just open this sin and cos, means if you write sin S, sin for S and cos for C, you will get this answer. Next one is xy is equal to e raise x minus y. We have to find dy by dx. So we'll do it using the log. So let us take log. Log a into b is log a plus log b. So you'll get log x plus log y. Here also log x minus 1 y will come in front. Log e of e, that is, it is going to be 1. And then we have to differentiate. Log x is 1 by x. Log y is 1 by y. And then dy by dx is equal to x minus y. So differentiation of x minus c is 1 minus dy by dx. So we'll take the dy by dx term together. Let's take this. So 1 by x will be equal to dy by dx you can take common. And since we are taking it all here and we'll get a negative sign. So minus dy by dx I'm taking outside. And this will go on the right. It will be minus 1 by y dy by dx. So if you take minus common, you'll get 1 plus 1 by y. So what do you get? Y plus 1 by y. And dy by dx with negative 1 minus x by x here. So dy by dx will be equal to, now just cross multiply. So this cross multiply, this is going to be x minus, I'm replacing 1 minus x with x minus 1 and removing the negative sign. So x minus 1 by x into y by y plus 1. Now this one, this is u, this is v, this is w. We'll assume it to be like this. And we will differentiate du by dx, dw by dx and dv by dx. And this one a to the power b, there is no x, so it will be 0. Differentiation of this will be 0. So we'll differentiate them and just add all of them. So if you have any idea, because this kind of question we have already done, all these separate part we have already completed. But for the sake of completion, u is equal to y to the power x. Log u will be x log y. It will be 1 by u differentiating. Du by dx is equal to differentiating x log y is 1 by y plus log y d by dx of x is 1. So what we will get? Du by dx will be what? U will go on the right hand side. So this is going to be u, and u was y to the power x only. X by y plus log y. First thing. Second thing, x to the power y. So now second thing we are doing, v equals x to the power y. So log v is equal to y log x 1 by v dv by dx is equal to y log x is 1 by x plus log x and then dy by dx. V will go on the right hand side. So dv by dx will be equal to x to the power y. Here y by x plus log x dy by dx. This is the second term. So du by dx, dv by dx already done. Now we'll go ahead with our x to the power x. So there will be dy by dx here also. See, x log y is 1 by y and then dy by dx. So there is one dy by dx which I left. So I am completing it right now. Okay. Now third one. We have w equals x to the power x. Log w will be equal to x log x. So 1 by w dw by dx is equal to x log x is 1 by x plus log x d by dx of x is 1. So you'll get 1 plus log x. W will go around the right. So we have x to the power x. Now I'll add them. We'll add them and equate it to 0. So this is going to be, please remember dy by dx was there. Okay, I just left it. Now I'm adding it. So dw by dx. So y to the power x, x by y, dy by dx plus log y plus x to the power y, y by x plus log x dy by dx plus x to the power x 1 plus log x equals to 0. Now just multiply, take dy by dx together, other terms on the right, and the term with the dy by dx in the denominator. That is what you have to do. You can just skip if you want, because that is what we do normally. So I'm taking the term x to the power x 1 plus log x on the right hand side. This is y to the power x multiplied by x by y. I'm multiplying it now. And then y to the power x log y. So I'm taking it on the right hand side. Y to the power x log y. Now multiplying this, x to the power y, y by x plus x to the power y log x dy by dx. So this also I'm taking on the right hand side. Please remember, x to the power y is in the numerator, x in the denominator. When x will go in the numerator, it will be x to the power minus 1. So you can add the power x to the power y minus 1. So it is, I'll just change it. There is a slight mistake I've done. I'll just change it. So it will be y into x to the power y minus 1. Okay, I change it. So the power are added. When it is in the new denominator, it goes up with a negative and then added up. So we have got almost things on the right. So things on the right are perfect. If you see the answer also, you've got this. Now we have to combine this dy by dx term. And what is remaining? Again, y to the power x by y will be y to the power x minus 1, as I suggested for the x also. So it will be x to the power x into y to the power by x minus 1. And then plus this I am taking outside, so it will be x to the power y log x. This is already done. So minus I am taking outside, and I'll just arrange them so that we get the answer the way it is expected. So y is x log y, and then y x to the power y minus 1, then x to the power x, and 1 plus log x inside. X to the power x, 1 plus log x inside. Okay, now in the denominator, it will be, just take this in the denominator, x, y, x minus 1 plus x raised y log x. So this is the final answer. Okay, you can just match it also. Negative will always be there. Numerator, denominator, numerator, denominator. Cos x to the power y and cos y to the power x, we have to find dy by dx. Okay. So it is quite straightforward also. Take the log on both the sides. So you'll get, if you take log, it will be y log cos x equals x log cos y. So it will be now differentiated. So it will be y log cos x will be 1 by cos x, and cos x differentiation will be minus sin x plus, now log cos x and dy by dx of y, dy by dx actually, equals, now x outside log cos y 1 by cos y will be minus sin y. plus, and dy by dx also. Why? Because we're differentiating y. And then log cos y d by dx of x is 1. Now the same thing, dy by dx on one side, others on other side. So we have this dy by dx I am taking common. It will be log cos x. This will go on here. And since it is negative, it will be positive on here. So x sine by cos is 10. You can write it as x tan y equals log cos y. Now this will go on the right. Again sine by cos is 10. So y 10 and this is on the right. So it will be plus y tan x. Now whatever is in the left, just bring it in the denominator. So it will be log cos x plus x tan y. Alright. This is the answer. Here we have cos y equals x cos a plus y, and cos a is not equal to plus minus 1. So we have to find out dy by dx, and you don't have to take log here. Basically all the questionnaires which we are taking, we have to have a log in this, but in this case we don't have. And this cos y is equal to x cos a plus y. It's worth mentioning that on the right hand side there is no x. So there will be some x replacement somewhere. Okay. We are not taking log as I just mentioned. We will be replacing right hand side no x. Okay. So this x will come from here. From here. Cos y is equal to x cos a plus y. So x will be equal to cos y by cos a plus y. That we are going to replace wherever it is required. So we have cos y, differentiation is minus sin y. Then differentiation of y is dy by dx. On the right we have x cos a plus y. So we'll use the product rule here. So x cos a plus y is sin a plus y minus sin a plus y. Then a plus y will be what? A is 0, y is dy by dx. Dy by dx here, plus then we have cos a plus y dy by dx of x is going to be 1. So we'll take this on left hand side. That is we are going to collect all the terms with dy by dx. So we have x sin a plus y dy by dx, and then on the left we have sin y dy by dx. So I'm taking the first term of the right on the left and taking dy by dx outside. So it will be x sin a plus y. And minus negative was already there, so minus sin y, and on the right we have cos a plus y. Okay, now this x, as I said, we will be replacing it sometime somewhere. Now there is the time. X is cos y by cos a plus y, so it will be dy by dx in place of x. We want to eliminate x actually, so it will be cos y by cos a plus y. So I am replacing x by cos y by cos a plus y. Sin a plus y will remain like that. Then we have minus sin y also. On the right it will be cos a plus y here. Alright. Now take the LCM now. So this cos y and sin a plus y minus sin y into cos a plus y. Sin y into cos a plus y. And in the denominator we have cos a plus y. Now this cos a plus y is ultimately going to be on the right hand side with cross multiplication. So I'm just taking it in this step only. It is going to be cos square a plus y. This goes up. So cos square a plus y on the right hand side. So the first numerator we have got. How about the denominator? See, sin a cos b minus cos a sin b is what? Sin a minus b. I am taking a as a plus y and b as y. So it will be sin a plus y minus y. So sin a plus y minus y, you can get it cancelled, sin a. And sin a is going to go in the denominator of the right hand side. So you have cos square a plus y divided by sin a. This is the term we wanted. Okay. Alright. Now the next term is x minus y e to the power x by x minus y, and this equation we have to form. So this type of question we have already done a lot of time. So x minus y e to the power x minus y. So when we'll take the log, what are we going to get? See, log a into b is log a plus log b. So log x minus y plus log e to the power x by x minus y. So as I said, when we take log, e means base is already e, so if it is e, it is just equal to 1. So you can just write x by x minus y in this place. So log x minus y plus x by x minus y. On the right also you are going to take a log, so it would be log a. So what we can do here, the basic thing is you have to now differentiate. Okay, so you have to differentiate both the sides. So you have log x minus y. Log x minus y will be what? 1 by x minus y. I'm differentiating you, so you have to differentiate all the term. d by dx of log x minus y is 1 by x minus y. And what is the differentiation of x minus y? It will be 1 minus dy by dx. Okay, then plus. Now this x by x minus y, differentiation of x by x minus y will be what? It is of p by q form. So we will use the quotient rule. So x minus y whole square, denominator whole square. X minus y d by dx of x is going to be 1. And then we have x minus, now x will remain like that. Differentiation of x minus y we have already done. It is 1 minus dy by dx that you have already seen. Okay, so now the only thing which we can do is to manage the things. Okay, manage the things means to see that the result comes as what is being asked. So there is just a rearrangement. Right hand side it is going to be 0 because differentiation of log a is 0. Now let us take x minus y whole square as the denominator. So x minus y, if you take x minus y whole square as the denominator, then x minus y will come for the first term and there will be no x minus y whole square term or x minus y term for the second part. So I'm taking the LCM now. Okay, when we multiply this x minus y whole square on the right, it is going to be 0. So only this x minus y, 1 minus dy by dx, and then plus x minus y, and then we have, okay, x minus y. See, we have to multiply. Okay, let us multiply, and then we will just collect the terms of dy by dx together. Okay, so I'm multiplying inside x minus y into x minus y dy by dx plus x minus y minus x and this x dy by dx equals to 0. So dy by dx terms together. So this whatever cancellation is possible, you can just cancel it out here. So one x will be cancelled because one is x, one is minus x. So you can just get this cancel it out. So there will be a negative y, actually negative y, there are two negative y's. So minus 2y will be remaining on the left hand side and one x will remain here. So this minus 2y, I am taking it on the right hand side. So it will be 2y on the right hand side. Okay. So there will be 1x on the left will remain. The minus 2y, I have taken it on the right hand side. Now I am taking dy by dx common. So it will be, as I said, 1x. There will be a y with dy by dx. Okay. So y dy by dx, and there is one more x terms that I am just going to add here, as I just indicated you. So we have already formed the equation. As I said, this is just a rearrangement. The only thing which you have to understand is you have to take a log, and when you take the log, you have to take dy by dx and then other things on right. Okay. So y dy by dx, and then y dy by dx plus x equals 2y, right? Okay, x equals e to the power x by y. Prove that dy by dx is equal to x minus y by x log x. Okay, so x is equal to e to the power x by y log, see, it's just understand log y equals x. If e is the base, so e to the power x is y. And the other thing you have to understand is when you take log and there is log e, it is actually 1 because we are taking log base e. Log e base e is 1 only. So you can just write x by y. So log x equals x by y. Now just cross multiply. Y log x equals x. So now I'm differentiating. I'm using the product rule. So y log x is 1 by x plus log x. So dy by dx is equal to d by dx of x is 1. So log x dy by dx equals 1. I'm taking this y by x on the right hand side. So 1 minus y by x. It is going to be x minus y by x. So log x come here. So dy by dx is equal to x minus y by x log x. Okay. Now this next question. Y is equal to x to the power 10x plus under root x square plus 1 by 2. So the power basically, you see, under root x is nothing but x to the power half. Third root of x is x to the power 1 by 3. So we have y equals x to the power 10x plus this term, under root term. So we'll take the log first, log y. And when we take the log of this, log x to the power 10x, 10x will come in front. Here also we'll take x square plus 1 by 2 to the power half. We'll take log. So log y is equal to 10x will come in front. So we have 10x log x plus half will come in front, half log x square plus 1 by 2. Okay. Now the next thing is to differentiate this. So let us differentiate now. 1 by y dy by dx is equal to now 10x log x. So we'll have this 10x outside, log x is 1 by x. Now log x outside, 10x is sec square x. Plus, now half log x square plus 1 by 2. Half will remain like that. Now log of anything p by q will be q by p. So it will be 2 by x square plus 1. Now differentiation of x square plus 1 by 2. So it will be 2 will remain here. X square plus 1 is 2x. So all 2 gets cancelled. We have, so I'm just writing in short 10x by x plus log sec square x plus x by x square plus 1. Now this y will go on the right and this y is this whole term. So I'm just writing it x by x to the power 10x plus under root x square plus 1. X square plus 1 by 2. Okay, so this whole term, and on the right also we have this term. So you can do one thing, you can just multiply the outside term inside, or you can keep it like that. If you multiply also, that will be one more step, but this step also you can stop. So I don't think there is any problem, but the only thing is that you can multiply inside and write the final term, which is this one. Okay. Now this question, so we have alpha, beta, gamma, and when we just resolve this, you will see it will be quite easy. So we'll take first we'll simplify it, and then we'll take the log, and then we'll take the differentiation. Okay, so 1 plus, this is alpha divided by 1 by x minus alpha. So what will come in the denominator? It is 1 minus alpha x by x. Now x will go up. So it is going to be x alpha divided by 1 minus x alpha. So what this will become? This is going to be alpha x divided by 1 minus alpha x. Next one, same thing here. So beta by x divided by 1 by x minus alpha. We have already done this just now. So you can just write directly like this. It will be 1 minus alpha x by x. No, not this one, because this is what we have got after the reciprocal. And the second part is 1 minus bx by x. So the first will be, let me just cancel this thing. Let me just cut this thing. So it is going to be 1 minus alpha x by x, and this is 1 minus beta x by x. So x gets cancelled. We have this, and this x will go up. So this is going to be beta x divided by 1 minus alpha x and 1 minus beta x. Alright. This is your second term. So beta x by 1 minus alpha x and 1 minus beta x. Okay. Now here we have gamma by x square, and there are 3 terms in the denominator. So we have gamma by x square, and then we have 1 by x minus alpha, 1 minus alpha x by x. Here also 1 minus beta x by x, and we have 1 minus gamma x by x. So there are 3 x's in the denominator, there are 2 x's in the numerator, so 1 x will remain. When you just cancel it out, it will go in the numerator. So it will be gamma x divided by 1 minus alpha x, 1 minus beta x, and 1 minus gamma x. So 1 minus alpha x, 1 minus beta x, 1 minus gamma x. Okay. So let us make it, we have just simplified it up till now. We've done nothing. Now we have to take log. Okay. So log 1 is 0. So just you can, get rid of this one, because there are 2 things which you have to remember. Log a by b is log a minus log b, and log a into b is log a plus log b. So I'm writing log alpha x minus log 1 minus alpha x here. Here also, again a by b form. So log beta x minus log 1 minus alpha x into 1 minus beta x, plus same here. So log gamma x and minus log all of these 3, 1 minus alpha x, 1 minus beta x, and 1 minus gamma x. 1 minus alpha x, 1 minus beta x, 1 minus gamma x. Okay. So this is log y. Alright. See, log alpha x, log beta x, and log gamma x, they all are in plus form. It means, and log a into b is log a plus log b. Because log a by b we already used. Log a by b is log a minus log b. That we have already used. Log a plus log a into b is log a plus log b. So log y is equal to this log 1 is, I am removing it. I am not writing it again because it is 0 only. And log alpha x, log beta x, and log gamma x, you can combine them together if you want. Or you can just keep it like that. Of x minus log 1 minus alpha x plus log beta x minus log a into b is log a minus log b. So minus log 1 minus alpha x and minus log 1 minus beta x. 1 minus beta x plus log gamma x already there. So let me write this log gamma x. And the third term, we have 3 terms. So it will be log 1 minus alpha x minus log 1 minus beta x. And then we have minus log 1 minus gamma x. So log alpha x, log beta x, log gamma x. Then we have log 1 minus alpha x. So there are 2, how many alpha we have? 3 alphas if you see. We have 3 alpha. So we have log alpha x, log 1 minus alpha x, log 1 minus alpha x, log 1 minus alpha x. There are 3 log 1 minus alpha x, so it will be minus 3 log 1 minus alpha x. So all this alpha term we have taken, this first term, second term, and third term. So log 1 minus alpha x, this one, and this one we have already taken. So 4 term already done. Log beta x you can just write like that, log beta x. And the log 1 minus beta x, there are how many 1 minus beta x term? There are 2. So minus 2 log beta x. Okay. So log 1 minus beta x, there are 2 of them. Log 1 minus beta x is like that. and then we have minus log 1 minus gamma x. Gamma x only is only 1. 1 minus gamma x. So log beta x and log gamma x. You can alpha x already taken, so plus log beta x plus log gamma x. Alright. Now let us differentiate. We have to differentiate now. So 1 by y dy by dx. And please remember, y is the whole term from where we started. This whole term. Alright. So we have this log alpha x is what? 1 by alpha x, and differentiation of alpha x is going to be alpha. So it is going to be alpha by alpha x. Alpha gets cancelled. You have 1 by x. And this will be same for log beta x and log gamma x. Every time you will get 1 by x. So I'm good. Minus 3 log 1 minus gamma, this alpha x, minus 3 log anything is 1 by that thing, and 1 minus alpha x differentiation is minus alpha. So minus minus will become plus. Minus 2 log 1 by 1 minus beta x, and differentiation of 1 minus beta x is minus beta, minus minus become plus. Similarly here also 1 by 1 minus gamma x and 1 minus gamma x. 1 minus gamma x is what? Gamma. Negative become positive. And here we have 1 by beta x and then beta, which I already told you, beta gets cancelled. And then gamma x, and here gamma gets cancelled. So we have 1 by x here, 1 by x, 1 by x, 1 by x. So 3 by x here. So let me write it again, all these term, because we are short of space. So I'm just writing it. This is 3, this is 2, this is 1. So you have to keep these terms, and on the left it is already 1 by y dy by dx. So y will go on the right, and y is the whole term which you see in the question. So 3 by x. So let me write it again. So 1 by y dy by dx, and as I told you, it is 3 by x. So it was 1 by x, 1 by x, 1 by x. So I called you, it is 3 by x. So alpha cancelled, 1 by x, beta gets cancelled, gamma gets cancelled. Alright. So 1 by x, 1 by x, 1 by x. Combine it together. So 3 by x plus. So what did we get here? 3 alpha by 1 minus alpha x. This was 2 beta by 1 minus beta x, and here we have gamma by 1 minus gamma x. So 1 by x we can take common. Let us take 1 by x common. We'll get what? 3 plus, so 3 alpha x. If we have taken x common, it will be 3 alpha x, no? So 3 alpha x, 2 beta x and gamma x. So I am taking this alpha x in the denominator. Let me show you to you here. It is 3 alpha x by 1 minus alpha x. So 3. This alpha x, if you take this x in the denominator, it will be what? 1 by alpha. I am just saying that I am taking alpha will remain in the numerator. X I am taking in the denominator. So that will give you the same term from where we started. It is 1 by x minus alpha. 1 by x minus alpha. This one. Okay. So 3 by 1 by x minus alpha. So 3 beta x by 1 minus beta x. What do you get here? No, 2 beta x divided by 1 minus beta x. What will you get here? X we are going to bring in the denominator, same thing. So 2 beta will remain in the numerator. 1 by x minus 1 minus beta x by x is 1 by x minus beta. So in the denominator you will get 1 by x minus beta. And third also you will get 1 by x minus gamma in the third one. So 3 plus 3 alpha by 1 by x minus alpha plus, and in the second I told you 2 beta by 1 by x minus beta, and this gamma term gamma by 1 by x minus gamma. Okay, this is see an additional term. I'm just saying this y has to be brought on the right. So y by x. So y is this whole term. Now this is just an additional question which is not in your in your book of this particular you can say edition. Just a added one. If you want, you can just skip it also. But the whole idea is to simplify, take log and then differentiate. Log, differentiate. This is the whole story of this whole exercise. So this is all about this exercise. Thank you so much. Take care of yourself.